Voy a hacer una pequeña introducción sobre al profesor Christoph. Después de más de 25 años de experiencia industrial, Chris Cole se incorporó en la Universidad de Alberta en el año del 2017 como director asociado de la Escuela de Seguridad y Gestión de Riesgos de nuestra Escuela de Ingeniería David and Joan Lynch en la Facultad de Ingeniería de la Universidad de Alberta de Canadá. Chris ha trabajado con la gestión, con legislación nacional e internacional, prevención, salud, medio ambiente y seguridad para múltiples jurisdicciones. Tiene experiencia con una variedad de modelos y sistemas de gobierno en temas de seguridad, medio ambiente y salud. Ha desarrollado e implementado planes estratégicos e iniciativas para administrar los riesgos relacionados a estos temas que se alinean y apoyan, que alinean y apoyan la cultura corporativa de cualquier empresa, industria, operación. Él entiende el valor de construir relaciones con varias culturas y a través de múltiples partes interesadas, incluyendo juntas de directores, gerencia superior, operaciones, proveedores, reguladores, socios y negocios y clientes. Chris cuenta con una experiencia en operaciones de petróleo, en upstream, incluyendo perforación, sísmica, producción, oleoductos, desarrollo en tierra y en mar abierto. Posee experiencia internacional, ha trabajado en varios países, entre ellos Canadá, Estados Unidos, Francia, Corea del Sur, Holanda, Italia, Reino Unido y los Emiratos Árabes Unidos y Qatar. Ha trabajado mucho desarrollando políticas, planes y procedimientos corporativos y de proyectos. So thank you very much, Chris. That's your introduction in Spanish. I'm happy to send it to you as well. And the venue, it's all yours.
Gracias, Carlos. Welcome, everyone. Buenos tardes. A quick question, Carlos, on the translation. Should I stop at the end of every slide?
No, it's simultaneous interpretation. So while you speak, Yvonne and Jose will simultaneously translate, but just speak not fast.
Okay, excelente. Well, my topic today is to give you a brief introduction to a very interesting area, process safety management, an area that I've spent a fair bit of my career around, and a very important area for those of us with technical backgrounds, particularly in engineering. The topics I'm going to cover today, I'll just give you an overview of my background, and then we'll switch into what we mean by process safety, why it is important, and we'll just look at some of the key concepts in process safety, particularly risk assessment, inherently safer design, a risk-based process safety management system, and then I just have one slide to share with you some closing thoughts, and certainly glad to answer any questions the best I can. So, as mentioned, I belong to the School of Engineering Safety and Risk Management here at the University of Alberta. And we're at 54 degrees latitude north, so we're a long ways north of the equator. So right now we're right in the middle of winter. Our days are really short and really cold. Here you can see our school, and hopefully you can see our pointer. We have Professor Winkle, who runs our school. And then we have 5 professors listed here who support Professor Winkle and our program. Dr. Machado in the middle here is actually from Peru. And I wish he was giving this lecture because it would probably come across much better, as Spanish is his native language. Myself here, I'm over here on the end, and I'm the associate director. When I look back at my career, I'll just share with you some highlights over 30 years of places around the world, as shown by some of these yellow dots that I had the very good fortune of working with through some of the companies that are listed down here. And when I look at my career, this slide here is a little bit busy, but I will take a few minutes to walk you through it, because it's very important to understand that when you're sitting there as an engineer getting ready to graduate in your senior year, you think you will have a very set path in your career. And I'm very confident that there will be many opportunities that come across to you that will take you in different directions and some very interesting areas. And when you look back, hopefully after 30 years like I do, realize I was very fortunate to work with some great organizations and meet some wonderful people along the way. So if I look on the left-hand side over here, I started my career with the company Mobile Canada here in Western Canada. I worked for several years, and then I had a degree in petroleum engineering. Then I went back to graduate school, 92, 93, and I went into environmental engineering in a master's. I did some environmental engineering work in British Columbia, a province next door to us on the Pacific. Then I rejoined Mobil Oil, and I had a number of assignments with them working out of Calgary. And then from there, I went to a project off Eastern Canada, Sable Offshore Energy. This is a picture of it. I'll share some more thoughts on that. It's another slide. From there, I went to the Middle East, close to Saudi Arabia, in a small country, Qatar, for several years. I came back to Western Canada, worked with Imperial Oil on some major projects. From there, I went to a Canadian company called Synovus. And not only did I work in safety, but I also worked in manufacturing performance, which was really interesting. From there, I went to a smaller company based out of Calgary called Verison. And we had an interesting portfolio, including wind farms, which I'll talk about here in a few moments. And then since late 2017, just over 3 years ago, I decided to come back to the university that gave me a great education and a start in my career, and to give back. And I'm very much enjoying teaching as an industrial professor. So my teaching is more geared around things I've learned through my career and sharing those lessons with students to help make them successful for their careers. I mentioned I worked at Sable Offshore Energy in Eastern Canada. Very interesting project. And this is a picture of a platform called TIBO. And here we have another compression platform, which we would compress our natural gas to send it to shore. And here we have another platform where we had some wells. And a couple things I would mention here is that this is a great looking day offshore. You don't see much whiteness in the ocean. And it's a very compact environment. So as you can tell here, the way these platforms are built, you build upwards. And these platforms bring a lot of risk due to their small size, their remote location, and the large volume of hydrocarbons that go through these platforms every day. So very interesting for risk management. I mentioned I worked in the state of Qatar on liquefied natural gas, or LNG. This was a project where we had some 30,000 people building our plants, and we were expanding quite rapidly to develop LNG to supply the Far East, Korea, Japan, and China. And at the time, we had a footprint of 1.6 kilometers by 1 kilometer. And we ended up building that whole part of land in terms of the size of our plant. It was a massive, massive project. I had the good fortune of working with people from 52 different nationalities. Just a wonderful experience. And also a lot of risk as well. Taking natural gas and chilling it and making it cold to get it ready for shipment is very interesting, but also has significant process safety risk. When I came back to Canada, I was involved in oil sands mining for several years, some major projects, which are large strip mines in northern Alberta, which have oil sand or thick mixture of almost like molasses and soil particles, and quite an engineering feat to be able to mine that bitumen, as it's called, and make that into a product that's usable. Also in Western Canada, when we have too much overburden or soil layer.
También en el oeste de Canadá podemos ver, y tuve la oportunidad de participar en el drenaje de gravedad asistido por vapor.
So we have a picture here of what's called steam-assisted gravity drainage. And these are actually oil wells where we inject steam and it helps loosen the oil. It's also thick like molasses and it drains into another well which is below it. And this was very interesting work as well.
Ha sido para mí muy interesante trabajar aquí. Y bueno, luego tenemos...
And I also supported 2 refineries in the United States, one in Wood River, Illinois. You can see an aerial photo here right next to the Mississippi River. And the other refinery was in Borger, Texas. This was a very old refinery, over 100 years old. Very interesting working with something that old and trying to keep it running safely and reliably every day. And I mentioned I spent some time working with renewables, and here's a picture of a wind farm in central Canada. And also very interesting work in terms of generating electricity through this mechanism, and very big operations in terms of the size of these wind farms, and some very interesting situations you find in terms of what's associated with wind. There's a phenomenon called flicker, whereby the light hits the blades and causes this kind of distortion. So there's a few trade-offs involved when you produce from wind. And then next door to us in British Columbia, where we have a lot of rain at times of the year, we have, you can see here in black, this is what's called a run-of-river facility. It's like a dam that you inflate when you have high water volumes and you want to divert that water through a turbine, which would be in here, to create electricity. But it only works well when you have a lot of water discharging through rivers. Very interesting work as well. So that was just an overview of some of the places and people I had the good fortune of working with over the years. So let's talk about safety concerns and types of losses. When we think of safety, there's 2 broad types. The first one, which most of us think about, is personal or occupational safety in terms of preventing injuries to people. Maybe when you slip at work, or you cut your hand, or you fall if you're on a ladder. The second type is what we call technical safety, and that's preventing some sort of unintended release of a form of energy. And process safety is a subset of technical safety. And when we look further at both of these categories, in terms of the type of loss incidents, personal safety, as I mentioned, it tends to involve maybe a worker, and some examples are giving here in terms of some sort of slip or cut or fall. And it's usually due to something in the workplace that's what we call a substandard practice or a condition. And when we look at the injuries, it's typically 1 or maybe 2 or 3 people. We consider technical safety is really we're losing containment. So something that has energy is usually contained or maintained, and we've lost that. And we have this unintentional release. Often it's a chemical or something that's hazardous, but can also be a form of energy. What's interesting with technical incidents is that the likelihood or how often they happen is very low. But when they do happen, the consequences or the result can be catastrophic. So the injuries can involve many, many people, a significant impact on our environment, a loss of an operation or an asset, negative publicity in newspapers and television, and your business may never recover. So when we talk about a process safety loss incident, it's usually due to some sort of chemical process operation when we lose containment. And many places in the world, if I look at United States with OSHA, they have very specific definitions for what we mean by a loss incident. In this example, chlorine is very hazardous. So when you release 5 kilograms, which is not a significant volume, that's categorized as a process safety loss incident in the United States that has to be reported and investigated. This picture also shows another way of looking at process safety compared to personal or occupational safety. So if we look at two things on our graph here, we have frequency increasing as we go across the bottom and consequences increasing as we go upwards. So as I mentioned, slips, trips, and falls tend to have lower consequences and are more frequent, and they tend to be personal safety. Versus process safety maybe is a major incident where you've released a chemical, it's had an impact off your site, but it's much less frequent. There is an overlap area between the two. Many times people spend a lot of effort thinking about personal safety, while process safety is not looked at as much, and we'll talk about that. Some of the key differences, as noted here, they're not the same, obviously, as I explained. But if we look at personal versus process safety, they tend to be very focused on work interactions, rules and equipment, training of people. So there's a lot of individual control over prevention. On process safety over here, it's very broader, it's a more systematic approach, and typically little control at the individual level. Some examples which we've talked about are falls and slips, maybe electrocution, some minor injuries. Here, the incidents, explosions, and fires and releases are much more significant. The safeguards, what we put in place to prevent these type of incidents in terms of personal safety, around things like work permits, PPE. If you think of coronavirus, a mask is PPE, guardrails, that sort of thing. When we look at safeguards for process safety, we have both design, which is a big part of our job as engineers, and also during ongoing operations. When we think further about process safety, it is meant to be both proactive and reactive. So when we think of being proactive, is what are the countermeasures we put in place to prevent something bad from happening? We perform hazard analysis and risk assessments, and we practice this concept of inherently safer design, which we'll talk about. On the reactive side, we also have to have countermeasures after something bad has happened to try to minimize further consequences. We take a deep dive on our incidents to truly understand why they happened. And we look at designing and installing layers of protection for after an incident. So you have to be looking at process safety through both a proactive and reactive lens. So when we think back on process safety, a defining event happened over 35 years ago in the United Kingdom at Flixborough. There's a major explosion, and it involved cyclohexane, a very tragic incident that was preventable, but it had major losses. After this incident, process safety got a lot more attention and focus in terms of industry and training and regulations. That was 35 years ago. Let's think of BP, Texas City, that some of you may have heard about. This happened just about 5 years ago, and this is an image from this incident, a tragic incident. So these incidents still continue to happen involving process safety, which is very terrible. So we say to ourselves, why are we not learning from these type of incidents? Why do they still occur? Why aren't things improving? some things for us to consider, some questions. Do you think sometimes that organizations spend way too much time on preventing slips, trips, and falls, but maybe not enough time on thinking about those process safety type of situations? Do you have the right personnel, particularly your operations and maintenance personnel, involved in making decisions? They are experts in your business. Another question, are you paying attention to what I call signals or indicators of something not being right and being proactive and using that information? This one here, the second last one, is a real big item. Sometimes you'll hear people say, it doesn't happen at our site, it only happens at other places, right? Are we sharing and learning the lessons of others? Or if you're at work, what does your senior leadership talk about the most? Are they talking about profits? Are they talking about layoffs and cuts and reductions? Are they talking about efficiency? And when they're talking about safety, are they talking about process safety in addition to personal or occupational safety? So let's explore this a little further. A key concept for us is risk. It's, as noted here, some measure of damage due to a hazard where we look at both the magnitude, the consequences, and the likelihood. So what are some of the things we think about is what can go wrong in terms of a hazardous event? Consequences, how bad can it be? Likelihood, sometimes called frequency, is how likely can it happen? We use both consequence and likelihood to estimate risk. So unlike other things we calculate in engineering, risk is more of an estimate. And we say to ourselves, if the risk is acceptable, something is safe. So this diagram at the bottom captures these concepts in terms of what can go wrong, how likely will it occur, what impact it could be. These areas inform our understanding of risk. When we think of risk criteria, as I mentioned, process safety are those events that have much more significant potential consequences, but their likelihood is very low. And we have to understand that everything we do, every activity, even things outside of work, driving a car, walking down the street and talking on a cell phone, skateboarding, all have a level of risk with those activities. And it's never entirely eliminated, and we end up with what we call a residual level of risk. And companies and organizations put in place criteria for the risk with their activities. And they use these criteria to establish a risk matrix, which we'll talk about here in a moment. And a key thing is that when we believe we have an acceptable level of risk, that is what is the maximum amount of risk that we can accept. And if something bad happens, we can live with it. So a risk matrix. Here's an example. And there are many versions of these. So this is a tool to help categorize risk. And it shows the relationship between severity in terms of consequences that are listed here, catastrophic versus negligible, and the likelihood, the frequency, very frequent here versus improbable here. In this example, which is mainly looks at personal safety in terms of injuries, we go from low, which is lightly colored, to yellow, medium, to lighter red serious to darker red high. So the risk increases as we go from this corner to this corner up here. So this is what many organizations use to help estimate the level of risk. So for us, when we think of process safety, we come back to fundamental questions. What are the hazards associated with our activities? How do we evaluate the hazards? What can go wrong and how? Then we think of risk analysis with several questions. How bad can it be? How often can it happen? And when we know consequence and likelihood, we're able to estimate the risk as a combination of them. And then, how do we control and manage this? So let's talk about an example that we're all familiar with. Imagine you're going to a service station to fill up your vehicle. And when we look at this through risk, how do we approach this situation? What questions should we ask to fill our gas tank safely? And I'm sure many of you have done this many times and probably do it in a way that you're not even thinking of the risk. So when we think of our questions, those fundamental questions of gassing up a vehicle, the hazards, what can go wrong and how bad can it be, how often can it happen, what is the risk, and how can it be controlled and managed. So let's think about the hazards. So here's a typical image of a gas pump with different grade of fuels. Here is a hazard card for gasoline that talks about the fire hazards. Different versions of this are used, but it's a common tool to help inform the public about the risk of gasoline. So when we think of a hazard, it's something that's inherent in terms of a chemical or physical characteristic. Because of that characteristic, it can cause damage to people, the property, or the environment, or all of these. For us, when we think of chemical plants, there are three main sources. The chemicals themselves, the properties, just like gasoline, is it toxic? Is it flammable? Will it react with other things? The equipment we're using, because we're worried about containment, so could we have potential leaks, equipment failing to operate outside of limits for operation, so several questions. And our procedures, how we start and stop if it's not correct. What if we have an emergency? What if we start the wrong equipment? So hazard identification becomes fundamental. When we think of what can go wrong and how, and look, imagine you've landed a dream job and it was a bad day at the gasoline station and your wonderful sports car, you escaped, but your car was lost. This would be a terrible day. So what can go wrong and how? A tool we like to use is what if. It's very commonly used, and it starts with a question of what if. I won't go through all of the questions here. I will mention some, but they all start with what if. This is a great way of evaluating for hazards. As an example, what if the vehicle fuel tank leaks? What if, number 7, the vehicle is left running? Number 9, what if the motorist is smoking? What if an earthquake or tornado occurs during filling? So you can see there are many what-if questions you can generate for this situation to help evaluate the hazard. How bad can it be? That's our consequences. And this is just an image from our consequence portion of our matrix. Pretty minor at negligible and catastrophic here. How often can it happen? We look at the likelihood in terms of the expected probability or frequency of what we call an initiating event, which is the first event leading to an incident. For us, we often use frequency. Here's an example of someone says, a pump could fail once in 10 years. That would translate into a frequency of 0.1 failures per year. And here is the example of our frequency portion of our risk matrix. Improbable, practically impossible, to very frequent up here, likely to occur repeatedly. And as I mentioned before, you put our consequences together with our likelihood to come up with this matrix. In the example of filling our vehicle at a service station with gasoline, we would look at each of the what-if questions and put them in one of these boxes. So if we said, for instance, the likelihood was remote, not likely to occur, for one of our questions, and the severity, if it did occur, was critical, we would say remote, critical, that risk would be a medium. And we would go through each of our 14 what-if questions to rank or assess the risk with our matrix. So after we've assessed the risk, how do we control and manage it? Here is a model that's used frequently. It's called the Swiss cheese model. Some important things on this model. So just like slices of Swiss cheese, which are depicted here, there are holes in the Swiss cheese. So if we start over here and we have hazards with our activities, I mentioned before we have safeguards. So we have two types of safeguards, preventive and mitigative. Preventive help us prevent incidents. But if these safeguards are not working well and they have holes like Swiss cheese, then those hazards could result in an incident. After the incident, we have mitigative safeguards, which are like barriers and slices of Swiss cheese. But if they have holes, then the consequences could be worse. So these mitigative safeguards are meant to reduce the consequences after an incident. So as I mentioned, very useful diagram to understand how hazards can cause an incident, resulting in significant consequences. Let's go back to our gasoline station. What are some of the safeguards? Maybe it has full service, so you don't have to leave your vehicle. There's somebody that's trained and competent in gassing up your vehicle. Maybe there's barriers in front of the gas pumps in case the vehicle loses control and it helps you from hitting that gas pump. You have a fire suppression system typically with phone. You've probably seen emergency stop buttons, both at the pump and remote at the attendant's desk. Warning signs and instructions. So this is a list of many safeguards that are present at gasoline stations, some of them that we don't even think about when we're there, to help reduce the level of risk to an acceptable level for filling our vehicles with gasoline. So we've talked about a simple example, common, that we've all seen. Let's reflect on a key concept called inherently safer design. It basically means it's an engineering approach or a mindset to have safety built in or risk built out. It came out of the chemical industry in the 1980s in particular. The Chemical Center for Process Safety provides us with this definition. It's a way of thinking about the design of chemical processes and plants that focuses on the elimination or reduction of hazards rather than on their management and control. For us, inherently safer design happens very early when we look at building a facility. That is much more effective than trying to incorporate this concept after a facility has been built. Unfortunately, this is not always the case. As engineers, we're trained to be designers, but often we think bigger is better. And why is that situation out there for us? Why don't we do better as engineers and designers? Some things to consider are human behavior. We believe our design is okay. Incidents don't happen at our site or for us because they're so low frequency. We've never experienced them. And for something we've never experienced, for most of us, it's hard to believe it will ever happen. And if it was going to happen, it would happen somewhere else. Another thing to consider is that we don't do a good job of looking at changes. Many incidents are involved with a change. So when we believe we're making a change to improve something, we don't always do the right amount of risk work to understand that change. So when we think of inherently safer design, there are four main strategies that approach this mindset of inherently safer. And I'll talk about each of these with an example here in a moment. From an introduction, the first one is to eliminate or minimize. And this means to use small quantities, particularly of hazardous materials or energy sources, or to reduce the equipment in terms of temperature and pressure. A great example is, we recall this earlier this year, there was a terrible explosion in Beirut that involved ammonium nitrate. A very large volume of ammonium nitrate was stored in the port of Beirut, which led to an explosion. If that volume was much smaller, the incident, while it may still have occurred, would have had a much less severe impact. The second one is to substitute or replace a hazardous chemical or material with something less hazardous. The third area is to moderate, to reduce the hazards by maybe diluting or using refrigeration type of process. And the fourth one is simplify, particularly in areas where you want to reduce the risk of human error. So I mentioned eliminate or minimize. Key concepts are to minimize the inventory and to look at your design and sizing of reactors and look at those to reduce the number of hazards when they're not in use. Here we have two examples, one of a tubular reactor, one of a semi-batch reactor, and both of these have design characteristics to minimize the inventory of product because they involve a reaction which generates heat. And when we generate heat, we can potentially have a runaway reaction. One that we're very familiar with when it comes to substitution is paint. Many years ago, a solvent-based paint was very common for a number of reasons. Now we use much more water-based paint. Much better for the environment, for our health in terms of toxicity, lower odor, and also for fires. So a common example that we see is with paint. Moderating, I mentioned trying to use equipment at less severe conditions, particularly temperature and pressure, or use hazardous materials in a least hazardous form. This example here shows us a ammonia concentration modeling going from 0 to 20,000 parts per million, and a reaction distance for a leak, for a failure. So this is from some consequence modeling for a small hole release, 5 centimeters, and the difference between using anhydrous ammonia and 28% aqueous ammonia. So we've moderated the type of ammonia here, and you can see, if you look at 10,000 parts per million, as an example, if you had a release, the impact distance is much different between the aqueous ammonia and the anhydrous ammonia. This example here, to simplify, is trying to reduce complexity, particularly for people. Generally speaking, the more complex, the more chance for human error. So here we have A and B, the same process in these two diagrams, but B is much more simplified compared to A. One common approach to use for inherently safer design is a checklist. I won't go into the details of all of these questions, but for each of the categories, for minimize, substitute, moderate, and simplify, we can have a number of questions that we ask ourselves as engineers to see how well we are applying inherently safer design. So this brings us to the topic of risk-based process safety. And what we mean by this is that organizations have moved towards a very holistic, systematic approach to maintain their integrity of what they operate. And process safety is very much about being proactive and involving these principles, which I'll explain through a model here shortly. A key thing for us is that the residual level of risk is never zero. You never get risk to zero. You get it to a level that's acceptable, as I mentioned. So when we talk about a risk-based process safety framework, there are 3 things to consider. The first thing is this idea of what people call a management system. And what we mean by a management system is where you structure and document all your practices, procedures related to, in our case, process safety management. We put those into what we call focus areas. In our model, we call them pillars, which we'll look at here in a moment. And we look at these further into what we call elements, which are specific focus areas. Right? A couple comments. For a management system to be effective, they need input and commitment from operations personnel, maintenance personnel to be effective. And they need ultimately commitment from the very top of the organization to support them, because they require resources in terms of people and expenses. And another key point is that once they're created and put in place, they are ongoing. They are always being evaluated and assessed for how healthy they are working, to make sure that you're continuously improving. This diagram speaks to a risk-based process safety system. For us, there are 4 pillars: commit to process safety, understanding hazards and risk, managing the risk, and learning from experience. So these 4 pillars become your foundation. And then we have these elements that are associated with each of the pillars. I'll spend some time talking through each of these to help give you a better idea of what they mean. This idea of a risk-based process safety system comes to us from the Chemical Center for Process Safety. The 4 pillars, as I noted, are listed here. And here are the elements. And what's interesting is managing risk has the most, almost half, 9 of the 20 elements. So let's talk about pillar 1 first. Commit to process safety. Element 1 is titled Process Safety Culture. What do we mean by this thing called culture? It's how we do things around here, what we expect, or how we behave when no one is watching. Why we have this? Because when we've looked at terrible incidents, there has been a weakness in the culture of the organization. And some key features to make sure you have a good safety culture are to particularly maintain a sense of vulnerability. Very important to make sure you're not overly confident that you feel vulnerable. Making sure people are empowered. Use your expertise. Make sure there's open and effective communications. An environment of trust. Culture, each strategy here is a cartoon that's sometimes used to drive home the importance of culture. What it means is that you can have the best ideas for your organization as a strategy, And unless you have a really good culture, it's going to be hard to implement or put your strategy in place. Our next pillar under commit to process safety, or element I should say, is compliance with standards. And this involves making sure you know what are the regulations and standards and laws and codes that are applicable. Even if there aren't any in place, what does good practice suggest from other areas? And why? Because we need to make sure people understand the importance of meeting those requirements, minimize our liability, operator facility safety, etc. Right? And how people do that, sometimes organizations develop their own requirements based upon the codes and regulations, or sometimes they have what we call our subject matter experts to review projects to make sure requirements are being met for regulation and codes and standards. Our next element, number 3, under commit to process safety, is process safety competence. What we mean here is a combination of our process safety knowledge, understanding, and experience within the organization. It's important because it's harder to measure than other areas, and we often have requirements in place for career advancement, and we have to make sure people are continuously improving their knowledge and competency, as you will experience through your career, and making sure the correct information is provided and is being applied consistently. So competency is a very important element. Element number 4 under pillar 1 in terms of commitment is workforce involvement. It means, how do we involve all our workers, particularly contractors? I mentioned to you the incident at Texas City, and that was during a turnaround at the refinery at BP. There were a large number of contractors, unfortunately, that were killed in that incident. So we had to make sure all people on our work sites are involved in making decisions. And it's important because those people that operate and maintain our facilities, they're usually most potentially exposed to the hazards of our operations. And they're usually the most knowledgeable about what's happening every day. There's really no set of rules how we do this, but it's important to make sure people actively participate. One model that I've seen used or talked about is kind of these 4 steps shown here. So the first thing you do is to engage people. That leads to their involvement, leads to further ownership, where they feel they can make a difference, and ultimately their commitment. So this is an approach I've heard spoken about. And you cannot expect to get commitment from people unless you've engaged them, involved them, and had them feel like they're part of the ownership. Very important. Element 5 under pillar 1 is stakeholder outreach. And this is a big topic today, particularly for us as engineers, understanding stakeholders, society's expectations of us to develop projects that are acceptable to the public. So for us, there's 3 key things. Who are those individuals and groups that can be affected by our operation? Then we establish relationships with those groups, other companies, and they were informing people about what we do. There was a time in our business of chemical plants where you really didn't tell a lot of what went on in your organization to the public. And that has very much changed in terms of people's expectations. And this involves what I would call a coordinated approach by technical people such as ourselves, engineers, but also experts in communications, experts in legal requirements. And here's an example from Scottish Power. They call it their 5 golden rules of engagement. First, take the initiative to get to know your stakeholders. Then they say, listen. No, really listen. They go on to describe the other 3. So very important. Not something to teach as much traditionally in engineering, stakeholder outreach, but certainly will be part of some of your jobs as you advance in your careers, I expect. So let's switch now to pillar 2, understanding hazards and risk. Element number 6 is process knowledge management. And it's important to capture process-related information in a number of documents, technical documents and specifications, engineering drawings, safe operating limits, material safety data sheets. So there's a number of areas where we capture a significant amount of information around our process, making sure people know where it is and how to use it. And it starts, if you're looking at a new facility or sometimes what we call a pilot, continues through design, construction, commissioning, and operations. This pyramid at the bottom here just shows an example of you have documents and records, you have procedures, and at the top you have your safety policy and objectives. Element number 7, hazard identification and risk analysis. Sometimes it's called HIRA, is part of pillar 2. HIRA is what we call a collective term that encompasses all activities involved with identifying hazards and risk evaluation to make sure the residual level of risk is acceptable. Some other words that you may hear used that mean the same thing are process hazards analysis, process hazards review, process safety review, etc. So we do this to manage risk, but we first need to understand our hazards and then assess the risk. This comes back to the 3 questions we thought about with our example of putting gasoline into our vehicle. What can go wrong? How bad could it be? How often might it happen? There's a number of tools we use for this. Some of you may have heard of hazard and operability study, or HAZOP. We mentioned the simple what if, failure modes and effects analysis, and also layer protection analysis. So these are very technical, very much engineering. I kind of like this little cartoon at the bottom here, which kind of does a nice job of showing the difference between hazard and risk. A hazard, in this case, is something that has the potential to harm you. So in this case, a person is standing and looking at the ocean and they see the fin of a shark. That is different from the risk, because the risk is the likelihood of a hazard causing harm. This case, the person is no longer standing, they're swimming, and the shark looks like it's closing in on that person. So that risk is very much from the hazard of standing on the beach. Or this other nice little cartoon, we talked about making sure we practice both prevention and mitigation when we talked about our Swiss cheese model for types of safeguards. So we switch to pillar 3, manage risk, and I mentioned the 9 elements are here. And this obviously 9 of 20 elements shows us the amount of work that a good organization puts into managing risk. Very important one is element 8, operating procedures. Those procedures are those kind of written instructions that detail step by step what we're expected to do to maintain a safe operation. Also, there should include guidance for troubleshooting when it's not steady state, or when you have a shutdown situation. And we need those to have a consistent level of how we conduct ourselves. They're typically developed by operators and ourselves engineers who are very knowledgeable of the operation. But we also rely upon maintenance personnel. Element number 9, safe work practices. Many of us are probably familiar with these if you've worked. This is the processes that we've put in place to help manage work. And some examples are lockout, tagout, hot work, line break, confined space entry. And often our safe work practices are required by some sort of government regulation. And again, just like our operating procedures, we need to have consistency. What's interesting is that safe work practices is one area where both process safety and occupational or personal safety overlap. If you recall on the diagram we showed, there's the two bubbles overlap in one place, and this is an example of where that happens. Here are some common pictures of different safe work practices, reminders that you may see in the workplace. Things from making sure you're using your office chair correctly, slips, trips, falls here in terms of keeping a tidy workplace, making sure that you're using your back correctly if you're lifting, if you have things stored at height, that they're secured, etc. So many of us typically think of these because they're much more frequent or common. Element number 10 under pillar 3 is asset integrity and reliability. What does this mean? We design equipment and we install it, and we need to make sure it means maintained fit for use until ultimately it's retired from service. And good asset integrity and reliability involves inspecting equipment, testing it, preventative maintenance, and even predictive maintenance, repairs, and a good quality management program. So making sure that our systems, particularly for us in process safety, key systems such as pressure relief devices, will work when needed. It involves a team in terms of how we do it, including operators, maintenance, inspectors, and engineers, sometimes specialized engineers that are experts in, say, rotating equipment as an example. And in many places, regulations require a program for asset integrity and reliability. Element number 11, contractor management. I mentioned before, it's very important that we have our contractors engaged. Many workplaces and the chemical, petrochemical business involve contractors to help our regular employees, especially during maintenance outages. We hire contract organizations. And why? It's because sometimes they have specialized expertise that's not usually available. Also help our resources when there's high demand periods, such as a maintenance outage. And also sometimes to maybe manage your cost. But the key thing is this: when you bring in somebody who's not usually working at your plant every day, that has a potential risk because they're not familiar with the culture, the hazards, all the systems you have in place. So you need to make sure you have a good program to screen those contractors before you award the work. You have roles and responsibilities established. You involve them in risk assessments, which is really good practice. And you provide them with the training for your site. And you're ultimately successful when both you and the contracting organization are achieving a good day where there's no incidents. Element number 12, training, performance, and assurance. And for us, we look at training being proactive instruction. Assurance, it helps us confirm how people understand their training, they can apply it. So a great example is when you think of getting a driving license for a vehicle. Typically, you have what we call a written test where you make sure you understand the rules and the regulations. And then you take a road test where you're sitting behind the vehicle and you demonstrate you're able to drive. So that's kind of a performance and assurance process. It's very important for obvious reasons. We need competent, qualified workers at all levels, from entry level to when you start your career as an engineer in training, to when you're maybe a senior engineer that's a subject matter expert. And so it's very important because people are such a big part of decision-making in organizations. How it's done, it can be done in the classroom, but also a lot of it's done on the job. And it's usually done with maybe a mentor or a coach. And it's usually done independently to make sure that you are qualified before you advance. It's very important for both your success and the organization. Management of change, or MOC, as I mentioned, is associated with many incidents. If I look back at my career, there was often a change that was associated with the incident. And we need to make sure we have a process to review and approve changes during design or organization operations. And it's typically, you should have it in place for anything where there's a replacement that's new or unique. And you assess the level of risk with the change to make sure it's at an acceptable level. This process for management of change, like the paperwork, the forms, can be quite rigorous. And because you want to make sure you're not introducing an unacceptable level of risk with the change. Right? And it's done usually by a team. And a team can involve people that work in the operation every day, to the project team, to the research development, depending on the nature of the change request. Typically, it starts off with someone who originates a change, and they have that then reviewed by a qualified person. And then they look at potential risk impacts. And then are there measures needed to adduce the measures to manage the risk? And then depending on this review, sometimes the change is not approved. It's rejected because the risk is too high and you're sent back to redesign. Very important, management of change. And it's important to have somebody sign off and approve it who's not part of the change. Element number 14 of manage risk is operational readiness. And it's really a check or verification that procedures or something that's modified are safe to start up. And sometimes you may hear this term, a pre-start safety review, PSSR. And that's commonly used. And we do this because incidents or loss of containment happens more often during periods of startup that are kind of different, these transition periods. And we use this for all types of shutdowns, maintenance, repairs, replacements. And sometimes it can be very simple, from one person doing a walkthrough with a checklist, or in some cases I've seen a activity that's lasted over a week with a very large team, reviewing not just what they see, but the physical records as well. So very important. Element number 15 is the conduct of operations to manage risk. And what it means is that how are you putting in place your process safety culture every day? And there's a saying we have in English, plan the work and work the plan, is one way of kind of thinking about it. And it's important because in all of these very complex operations that we design, human performance is such an important aspect to make sure that we have really robust operations personnel that are able to understand what's going on in the plant and make the right decisions and support one another, and people aren't taking shortcuts. Right? So what are the important aspects of it? We need to have good procedures, and those procedures are being used and followed. If those procedures aren't working, people are trying to understand why. We maintain our equipment, we do management of change, and we do auditing, which I'll talk about in a moment. So this conduct of operations takes several concepts and puts them together in terms of how you're putting in place your process safety culture. Element 16, emergency management. While we never want to have emergencies, we do need to make sure we have a plan in place if they do happen. So what this involves is planning for emergencies. What are the potential situations you could have at your plant? Making sure people are available to follow the emergency response plan. How do you practice it and do drills? How do you train people, your employees, contractors, maybe your neighbors, your local regulators? How do you communicate during an emergency? And we have what we call the PEAR principle, or PEAR. And what that means is that when we think of emergencies, we need to think of people, which is P, the environment, which is E, assets, which is A, and R for reputation. Because emergencies can get a lot of negative media attention, which we don't want. So we want to make sure we're protecting people both on and off our site and our emergency responders, and we're able to respond to these potential situations and communicate. How we do this, we have typically emergency management specialists in an organization, and we look at what are credible scenarios and what are the action plans we need to have in place. And there are very structured systems to practice for emergencies. One of the most simple emergency management drills you're probably familiar with is when you were in school before university and you had a fire drill at your school to practice, make sure people could safely evacuate the school classroom and gather in an area, a muster location, where you could be counted by your teacher, making sure everybody was accounted for. Element 17, incident investigation. And this is how we report and track incidents. Everything from the tools we use to ask why and how, who's on the team, and how we share lessons learned, how we follow up on recommendations for corrective actions. Why? Ultimately, we want to identify and eliminate those causes, those underlying causes to improve our performance. Right? We need to make sure when we have an incident, we look at both what happened before the incident in terms of improving, but also how we responded after the incident in terms of our emergency response. And also, some of you may have seen what we call a safety alert or safety bulletin. The best organizations share their learnings in terms of their lessons learned. Interesting diagram here. We increase the depth of our analysis through very good investigations that ultimately want to look at culture. So we just don't want to look at the immediate factors for an incident, but we really want to drill down deep. Imagine it's the analogy of peeling an onion, where you continue to peel layers to get a better understanding of why the incident happened. And usually you ask the question why and how, and you keep asking that question until you can't answer it anymore. Element number 18 for pillar 4, learning from experience, is measurement and metrics. So what we mean here is, what are the performance indicators that tell us how effective our management system is? And a good set of indicators allows us to have real-time monitoring and to be proactive. And when we think of these indicators, we use terms called lagging indicators and leading indicators. And you need a lens or a view of both of those. So in this diagram, which comes to us from the American Petroleum Institute, the top of the triangle has lagging indicators. And what we mean here is that something has already happened. It's a lagging indicator. So what they call tier 1 is a major process safety incident. And tier 2 is a process safety incident, but the severity is less. And then leading indicators are, in this case, tier 3 is a challenge to your safety system. And you look at tier 4. So good organizations look at both lagging and leading indicators. Because usually, if you're doing well, you don't have many lagging indicators, but that's not necessarily a reflection of good performance. And you need to make sure you're looking at the bottom here for your leading indicators as well. Element 19 of learning from experience is auditing. And some of you may have heard this term before. It's an independent review of how well you're meeting what's expected. It's meant to be proactive, to identify the gaps or deficiencies with your management system. And it's usually done with a team of auditors that use what we call a protocol, or a number of questions that are consistent, to see if, one, you have a program in place, something actually documented for how you're going to, say, design your facility, and two, how effective or how well you've done on implementing it. And an audit will involve looking at both the records, the information that's written down, and interviews with key people. And this brings us to element number 20, which is management review and continuous improvement. And this is similar to an audit, but it's more frequent. It's probably less formal. So it's more of kind of a regular checkup, where audits are maybe done every 3 years. And it's probably maybe done by one person versus a team. So in the example I give here, the training coordinator at your site leaves unexpectedly, maybe they win the lottery, and you want to do a quick review to see what this change may mean. Here's a good example down here of there's a famous methodology out there called Plan, Do, Check, Act, PDCA. And as you do these type of Plan, Do, Check, Act kind of reviews, you continuously improve yourselves moving up here in terms of your quality increasing. So that brings me to the end of the elements. Now I would like to wrap up with some closing thoughts for you when I look back. And here we have Janus. And January is named after this mythical person who's looking back as an older person, but also a younger person looking to the future. And what do I think in terms of your careers? Well, you're at a very interesting time in history. The change that our world is experiencing, that we'll continue to experience after COVID, is behind us. We're in the middle of an energy transition, and we will need your skills as technical engineers to be part of that. The second thing I would like to share with you is that you may not know it, but all of you are going to be risk managers through your careers. And you will need to make risk-based, informed decisions. The third item I would suggest to you is that when I think back in my career, I sometimes had opportunities available that seemed significant, maybe a bit overbearing, maybe beyond my reach. So I felt like sometimes you needed courage to adapt and grasp those opportunities, but also beware there may be situations of what I call destructive testing. And what I mean by that is that you are pushed too far beyond your capability. And that's probably not good for you on many levels, not just in terms of your results, but also your mental health. So be aware of that. Also, when you go to work, I would suggest you find like-minded people to be successful. Those will be very important people to be around, to get to know, to help you grow, understand an organization. The last item I would suggest to you is make sure you have some fun along the way. If anything, this year has taught us, a year like no other, that you have to take some time out to have some fun along the way, because life is very precious. So I thank you for your kind attention. I will gladly do my best to answer any questions you may have.
Ok. ¿Me pueden escuchar?
Sí, correcto, Carlos.
Ok, tenemos algunas preguntas.
Hello, good afternoon, everyone. I hope you had a great lunch. And we know that after taking the lunch, it is very difficult to concentrate on the session. But we have a very excellent speaker with us, so will be definitely keep us engaging for entire session. So, and she is a very famous personality in the process safety management. I am sure that you must be knowing her very well. And her name is Geetali Thakur. She will be talk on the interlinkage of industrial hygiene and process safety assessment. So it's my pleasure to introduce Geetali Thakur. Geetali is a chemical engineer with advanced diploma in industrial safety with a MBA degree, and she's also qualified licensed faculty from BOHS UK. Geetali is currently head of EHS function for the API and process safety at Cipla Limited. She has more than 20 years of experience in the process industry with 12 plus years in the core EHS and plant operation. And her major expertise in the process safety assessment, building inherently safety operations, occupational hygiene, and many more. She is also a board of reputed industry forum, including Green Triangle Society, Confederation of Indian Industries, and Indian Chemical Council. So let me hand over this stage to Geetali. Geetali, over to you.
Right. Thank you, Amit. Thank you so much, and sorry for the glitches. 2-3 minutes happens once in a while, given it's a new platform. And really very excited to, in fact, really connect to all of you virtually, and very happy that now we are really not really sure about what would happen in a few months, but so far I did in fact also attend a physical conference some months ago, so looks like things are normalizing, which is kind of a good news. And I would like to thank Priyanka for this opportunity. And Priyanka, on behalf of congratulate on the great job that you are doing. We all are really proud of you, the way you are really taking up CIHA ahead in this area of work. And for me, CIHA basically has a, I have a very, I have a different bonding altogether with CIHA. It was in 2015 when, in fact, Maharshi Mehta contacted me asking whether I could take up a session on what every industrial hygienist should know about process safety. And I was quite delighted. Those days, number of conferences, especially in the area of EHS, used to not be really so many. And industrial hygiene was even more lesser. So I think it was the second CIHA conference. And it was at Mumbai. I also have another bond with it because it was during my first trimester for my second child. And so I was kind of thinking that, I've been training her right at the beginning. So when at around 1.5 year old, when he went on the stage and in fact performed, and he was given the best youngest performer on the stage award, I told my husband it's about CIHA. So that's really my bond with CIHA. So thanks to all of you who are there around, and I really I would really be very happy to have this as more or less as an interactive session. So Priyanka, or maybe anybody else in the call can just confirm to me, audio is also allowed, or we have all the participants only for the live chat?
We'll be using
audio is Priyanka.
Yeah, we'll be using the chat function for participants to come back to you, Geetali, and you are on audio and video both. So thanks.
Okay. Thank you. Right. Fine. So we move ahead. And so today, in fact, I'm going to really, we are going to interlink the industrial hygienist jobs and the process safety risk assessors and risk assessments, and really try to see what is it that's common, what's really, where there are similarities, how it's integrated, and how there are certain areas which still, in fact, require, it does require, in fact, to let the specialist do his or her job. Like, I say that to process safety assessors many a times, or sometimes, in fact, that, isme to sach mein industrial hygienist chahiye. So those are some of the discussions we'll have, and we could move to the next slide. Yeah. So as I said, IH risk assessment, process safety risk assessments are carried out really by the specialist. And, it is important to recognize when to escalate certain type of risks to the other area of work. And also, in fact, sometimes when this integrated assessments have to happen. And at the end, the residual risk if it happens in isolation. What I mean is, if in a particular let's say project, if the assessments have been only related to process safety and not really industrial hygiene assessments have not happened, or the other way around, it is in most of the cases that I've seen, and I've done more than 500 basically heads ops, as well as, in fact, I've carried out more than I would say at least around 50 of this qualitative risk assessments for industrial hygiene. So I can surely tell you that if this both are not done and not integrated, the residual risk may not be really the tolerable level. So we can move to the next slide. Yeah, this is a mandatory disclaimer from CEPLA that I have to give. So these are all my opinion and not to be quoted from CEPLA anyway. You can move to the next slide. Yeah, so for me, it's very simple. And I think as EHS function with 20 years of experience, out of which 12 years has been in EHS, I really find it very useful to sort out things or maybe simplify things for in fact, especially for people who are not from EHS function. And over a period of time that, it's something that I've really tried to simplify really maybe in my brains, or you can say to people whom I speak to, especially on the shop floor, that industrial hygiene, what does it do is it's really trying to prevent illness. So it's really about prevention of illness. So it's about occupational hygiene, right? So occupational medicine is something which really comes into picture once the illness has occurred. And that's really the beauty of industrial hygiene, is that we are doing a real noble job of preventing somebody's ill health. And process safety, a very simple definition, is letting the process material remain in the pipe. So where it has to be, just remains there. That's the purpose of actually process safety achieved. And both these things together as EHS functions, I always tell my guys from the EHS function that you are the person between a person on the shop floor and his family. So you are the one who take a lot of decisions from your risk assessment for that person who is supposed to do certain job in certain manner based on what decisions you have taken and decided that this is a tolerable risk. So both these things, whether industrial hygiene or process safety, does take us to that particular point of having safe operations, really ensuring that the guy on the shop floor is safe, and with one really inclined towards health and another one inclined towards safety. We can move to the next slide. So before even we move ahead, the way this particular talk is structured is we will look at the tools that we used in different risk assessments. Not much into details, but really about speaking about what is it that we carry out. And then I promise you that I'll not bore you anyway with theory. I'm going to really have an interactive session with all of you with a lot of case studies. So I with that, in fact, we can start with the theory part first. Yeah, and I sometimes I give a disclaimer also that I'm more like a teacher rather than a speaker. So bear with me at times if I really end up being on that mode. So for process safety risk assessment, we start with the process safety information. So that's really the first data point where we would talk about whether the chemical has what kind of boiling point, what kind of, let's say, the whether it's a physical form, is solid, liquid, what is the physical properties of that, the chemical properties of that particular chemical. Then, in fact, what is the compatibility of different chemicals that we handle? All that comes from the process safety information. The next part of it actually is about the major hazards. So the major hazards are like the explosion, fire, overpressurization. So all of this is really the level 2 of the risk assessment. The level 3 is when we talk about HAZOP and we talk about going on to the line by line PNID, looking at each wall and then trying to see, what really can go wrong with different deviations. Level 4 is when we talk about the pre-checking that all the bases, the design intent that we had spoken about, has that been met, or is there something different then? Has anything changed? So before we really, in fact, get into the inauguration of that particular facility. And the last one is where we talk about its commission. Now we do the commissioning review, or after 5 years, we revalidate to see whether our basis that was considered for this particular project remains the same or not. So that's about process safety risk assessment. We can move to the next slide. In terms of industrial hygiene risk assessment, and why we are looking at these two slides is we'll try to see what is it that is in common, and then we will look at what is it that is different between the two. And then we will look at when is based, and then we'll look at some case studies which talk about when is it that, ring the bell of process safety or ring both the bells. So in industrial hygiene risk assessments, as we all practice here, we really look at what is the health hazard category, and that is based on number of toxicological information related to that particular chemical that is handled, including the OEL limit of it, and then the task, what are the tasks or the activities that are to be carried out. So that's actually the step 2. Then we carry out a qualitative risk assessment, and the qualitative risk assessment really looks at different different parameters. We have a slide on that more into details. And then based on what the qualitative risk assessment has concluded, we would look at workplace exposure monitoring. And then the last one is basically reviewing the control and the risk assessment ranking based on the so if the workplace exposure monitoring has given me a data which says that no, you considered this particular risk to be acceptable, but my data is saying that it is not acceptable, we are much beyond the OEL limits, so I would really go back again and in fact correct my understanding of that particular risk assessment and then review the risk assessment. We can move to the next slide. So this is a little on how a process safety risk assessment would look like. And we would talk about different deviations, and we would really look at maybe, if we are doing a tanker unloading, or maybe let's say we are doing a particular reaction in a reactor, we would look at what happens in case if there is more amount of that quantity added, less amount of that quantity added, the whole of reactant A gets dumped, and my reaction temperature goes about the adiabatic temperature. And with the adiabatic temperature rise, the kind of solvent that I'm using, it ends up boiling off. So let's say that the temperature of that boiling point is 90 degrees centigrade, and my adiabatic temperature rise with this dump is let's say 100 degree. So that boil off leading to overpressurization is all of those kind of process safety risk assessments that we would really look at. And so we would kind of do, in fact, these kind of risk assessments, and then really look at what are the safeguards, and then say that, these are the kind of controls required. Another thing that I want to really talk about process safety risk assessment is the number of risks from process safety perspective. The kind of focus is so much on things that should not lead to offsite emergency, something that should not really lead to reputation damage, something that should not go to the innocent people around in the community, or in fact in the neighboring factories, is so much high that quite a lot of time things like acute exposure, chronic exposure due to loss of containment, or due to probably handling of that chemical, let's say drum charging and other things, could be really not looked into so much of details as much as what we would really do with our industrial hygiene assessments. So probably I ended up telling you some things in advance in the slides, but I couldn't stop it there. So yeah, we could move to the next slide. Whereas in the chemical exposure risk assessment, what we have is we write down the work activities. We really try to see now whether this is a cow, this is a goat, this is a tiger, right? This is a lion. So that's really about, whether it is the, so based on different, as I said, toxicological data. So in majority of our case with the exposure, and in terms of industrial hygiene, just, I did not really clarify that. I'm not getting into the physical hazards, biological hazards, heat, stress, basically into the physical hazards or even the psychosocial. Though those have a lot of link to the chemicals also, but I'm really trying to keep it really with chemical exposure assessment, because our chemical exposure, because we spoke about process safety as trying to keep the process material in pipe. So it's really something which is surrounding around chemicals. So that's how, in fact, I'm trying to take the chemical exposure assessments and process safety together. And right, so here we would look at, so now my tiger is really that, OEL, basically the OEB band 5, and I have CMR chemical handling. So my majority of risk comes from what type of chemical I'm handling, and it's quite straightforward when it comes to the qualitative risk assessment with industrial hygiene. And the probability then is really based upon different type of I would say, parameters, like quantity that I'm handling, what is the kind of operation that I carry out, what is the boiling point, or what is the particle size of that particular material. So these are the different things that we would really have in terms of this chemical exposure risk assessment. Can we move to the next slide? Yeah. So what are the similarities? Yeah. So that's something, when any particular point to start, and when things are rosy and everything good, that's what we kind of look at. Oh, this is also good, that is also good. So it's like, just let's first look at what are the similarities between process safety and industrial hygiene. So ideally, both the risk assessments are expected to be carried out at the project stage. For me to really decide in terms of industrial hygiene, for us to decide what kind of, let's say, the engineering control we require, what kind of PPEs to be required, what kind of, so all of that is decided at the project stage. That's the first similarity. Once that is done, and once we have our equipments, in terms of process safety, we would carry out water trials. So we'll let water be taken through the system. We'll see if anything is leaking or not leaking. We'll look at the solvent trial. Whereas here in this case, for let's say certain kind of potent chemicals, we do carry out the surrogate test, especially when it comes to the isolators. The other thing is with the management of change, and that's what I practiced, is the management of change. If it is about any particular change in the existing system, let's say that I'm changing it from tanker handler, from using a particular chemical with tanker, instead of that I'm going to use it in drums. I would go ahead and I would do a risk assessment from process safety perspective, as well as I would actually go and update this particular qualitative risk assessment, and I would say that this is the revision number so and so of that particular industrial hygiene qualitative risk assessment. And I would now, in fact, have that particular MOC number saying that this is for this particular change, I'm doing this particular risk assessment. So what I'm coming to is, both these risk assessment documents have to be live. So what my operator is handling, what is live infrastructure in the plant, should be, in fact, reflecting in my risk assessment documents. And the last one is on the pre-startup review. So on the pre-commissioning review, similarly, we have the IH walkthrough assessments before we start. Yeah, so we could move to the next slide. Yeah, so that was all about the similarities. Now, when we talk about what are the differences, and I was not really able to get the best of best risk matrix from process safety, but something that I could really pull from the public domain is for process safety. As I said, the real focus is, can there be a bigger emergency happening? Can there be Bhopal tragedy kind of catastrophic incident occurring? And that's how, in fact, if you see the frequency, it is really about whether it can happen once in 10 years, once in a year, once in 10 years, once in 100 years, once in 1,000 years. And I remember one of my site head used to tell me, Gitali, it could be that once in 1,000 year could be this year also. So I want to keep it really clear and safe. So, but then that's how is the risk matrix that works. We could click next. Yeah. Whereas for qualitative risk assessment for industrial hygiene, it is very simple. It is we are either in green, amber, or red based on our qualitative risk assessment. We have done a qualitative risk assessment, and then that takes us. What we look at is we look at in those 8 hours of operation, what my operator is going to be actually handling, and that's how, in fact, most of these industrial hygiene assessments are carried out. Can we move to the next one? Excuse me, I'm at Indore, not a very common thing for a Goan. In Goa, the humidity is high, so I'm really requiring more of water. Yeah. So I hope all of you are ready for a more interactive session. And this is, yeah. So this is regarding the first case study, and it's about chronic exposure during sampling. And let me explain this particular thing. So all of you will have an opportunity to really put your comments in the live chat when we go to the next slide. So this is, yeah, we can click next. So it's about 3 batches per day and 15 minutes of sampling and around 50 ml of sample. And the boiling point of this particular chemical is around 90 degrees centigrade. It's an intermediate. And so I would like, in fact, the participants around here to tell me what kind of risk assessment should be carried out. Can we click again on next? Yeah. Okay, I shouldn't have asked you to click on next. You are right. So what kind of, let me see. What kind of risk assessment should we carry out? STEL, stale, okay, fine. So Hitarth Mehta, nice. So you're saying that we should actually carry out the monitoring and look at the short-term exposure limit. Wonderful. You just picked up that 15 minutes so well. I think you've given the answer yeah, correct. I mean, you've gone beyond the answer actually, Hitarth. So it's about carrying out industrial hygiene assessment here, because process safety, I'll tell you, go to the next slide. Perfect, Vijay. Yeah, again, click one more. Next. Right. So what would end up happening if we do the process safety risk assessment for this particular sampling is that the risk matrix will tell me, maybe click one more. Click, yeah, correct. It will tell me somewhere around, the pink indication that you can see. If I do a process safety risk assessment, it would tell me I'm kind of really into control with this kind of 15-minute sampling. Whereas, because it's 8 hours and because it's a potent chemical, I think we did mention there that it is a CMR chemical. So it's a tiger, right? So the health hazard category in itself is of highest category. And then it's getting multiplied by the probability. So in most likely condition, the raw risk based on the type of chemical that we handle with the qualitative risk ranking would really come with the highest of this ranking. And then we would really look at what kind of controls we require. We want something which is a high containment. And then based on that, we would really design the right type of engineering control for the guy who is going to be doing that sampling, right? So as I said, we are the one who are between the person on the shop floor and his family. Okay. Next slide. Next, yeah, correct. So case 2 is about loss of containment of chemical. We can, yeah, next, right? Yeah, let's remain with pink. Yeah, okay, fine. Yeah, let us remain here. So the activity is that the product filling is carried out in IBC. And in this case, right, it has, so it's about 100 degree centigrade is, so in fact around 1000 KL is the 1000 liters is the IBC, and the boiling point of the chemical is around 90 degrees centigrade. So in this kind of scenario, for a loss of containment leading to acute exposure, what is the kind of risk assessment that we would expect? I expect more of them to be on the live chat now. So that's an activity. That's a IBC filling as an activity that we are carrying out. And we have, so this loss of containment is the scenario that we want to capture. Dekho, मैं teacher हूँ, I'm a teacher otherwise, right? So I'll look at who are the attendees around. Hope I'm audible.
Yes, very much audible.
Okay, good. So let me pick it up then. So it's that we would really go for process safety assessment in this case. Process safety is where, in fact, it will look at acute exposure due to loss of containment. And I'll tell you why. Because the kind of, what would industrial hygiene assessment do in case of we using that chemical exposure sheet, right? It is anyways going to go to the highest level. It is going to tell us that we are into red. And at that point of time, it's going to have some kind of standard controls that would be actually recommended, like the highest level of PPs for loss of containment scenarios, as well as maybe in wherever possible, there would be some amount of spot extraction or some kind of extraction wherever possible. Beyond that, whatever kind of chemical it is, it wouldn't really give anything beyond that. Whereas from process safety perspective, here in this case, it could be really a fire scenario, or in fact, with the dominoes effect, it could be actually bringing down that whole of the facility. We could click next. Anybody wants to talk about what kind of controls? Perfect, Hitarth. Anybody wants to talk about what kind of controls should we have in this kind of scenario for this particular case study? So we could look at why do we really fill it in IBC first of all. So could this be actually done in, if we are actually really filling it 1 KL, can that be really sent in tankers? And I've really done that in past. From drums, which did shift to actually tankers. And so that was really a contained way of doing it. Exposures reduced down. And in fact, even from the process safety perspective, it made things more safer. Okay, can we move next to the next slide? Yeah, so right. So, okay, just back. Yeah, so as I said, the industrial hygiene risk assessment would anyways take it too high, and we wouldn't be able to conclude for loss of containment scenarios with industrial hygiene kind of risk assessment tool. Okay, we move next to the next slide. I hope you all are liking these case studies. As I said, I wanted to keep the participants engaged with these case studies. Thank you. Right. So the third case study is of use of a decontamination trolley prior to maintenance. Let's move to the next slide. So let's imagine that a pump has to be taken out for maintenance. So what we would try to do is, in fact, that particular pump will be flushed with solvent. We would blind it. In fact, we would blind the suction discharge lines, which are otherwise going to the other vessel or reactors. And we would really decontaminate it using this particular trolley. And if you can see, there is a small pot there, and then there's that particular hose. So the hose will be really connected. One will be connected to the pump, and then the other point would be really connected to this through this particular pot. Now, in this kind of case, what type of risk assessment would you really look at? And it can be used for any kind of chemical. Okay, I'm just trying to give you kind of approach on how do we really handle the ambiguity when it comes to these kind of assessments, where now this decontamination trolley is used for any kind of chemical. Anybody wants to take it? What type of risk assessment, what kind of risk assessment would we really go ahead with for this activity? Good. Ayash, very good. Very good, Avni. Anybody else? Ayash, very good, Hitar. Nice. So we would do the IH assessment, and we would also do the process safety assessment. But perfectly captured that a IH assessment is required. And we don't have audio, otherwise I would have asked why did you say IH. But I'll give you the background. I had to do an assessment for similar kind of activity. And what was happening is we brought this particular thing as a control so that we don't open the pumps with with in fact potent chemicals, the CMR chemicals that we were handling. We didn't want to open and send it for maintenance without really decontaminating. And what ended up happening is that that's good, Hitat. And so what ended up happening actually is that the vent of this was actually left in the left locally, the pot vent. And we ended up having more emissions over there from the pot because this, first of all, the solvent that was used for decontamination, as well as now the potent chemical was getting dissolved into it. And then the vent was actually connected to a particular scrubber. So when it's getting connected to a scrubber, that's where the process safety risk assessment would come into picture. So in this particular case, perfectly said, Avni and Hitar, that it's the industrial hygiene assessment is very much required, because it's not only about using this decontamination trolley to decontaminate. Now you just see the fun of this assessment is that it is not about a CMR chemical anymore. It's about a solvent that is used in the pot to decontaminate, as well as how we are going to actually now, in fact, drain or in fact, remove this particular solvent from this particular pot. So the fun actually is about the decontamination solvent that is used for decontamination. So you're right. It's the IH assessment for this particular activity, and the process safety risk assessment, because the vent of this is actually connected somewhere. So good. We could move to the next one. Yeah. So as I said, the venting will ensure that the containment approach is, it is then the complete thing is contained. Also, when I'm talking about ventilation, what I'm talking about is when I'm going to drain out of this particular pot. Now, the CMR chemical, which has 5 ppb, 10 ppb as the OEL limit, the ELV limit. Instead of that, we have it now dissolved in the lesser, what you can say, hazardous chemical, which is the decontamination solvent. But in spite of that, we are going to actually drain some amount of that solvent. And when you're draining it, maybe you can have something like a spot extractor where you're draining it out. Or maybe you could do that activity in a laminar flow both. Okay, so let's move to the next slide. Yeah, so in this case, one more click. Yeah, so in this case, right. So in this case, without the decontamination, it would have been surely the highest hazard. And from the industrial hygiene point of view, it would be somewhere between that. So, right. Okay. Let's move to the next slide. Next. Yes. So this is what I wanted to, in fact, include. that it's not just only about decontaminating it, but also to look at because we are going to also in fact use a solvent which has lower vapor pressure. We are going to be using these toxic chemicals. So this is my favorite gadget actually, the PPB ray, or you would call it as a VOC meter. So when we are doing this particular activity, we really try to see from which hose, or in fact, which particular joint are the emissions coming out. So you don't need to be really doing a workplace exposure monitoring quantitatively by calling some third party. But for such kind of activities where, it can be any chemical that is taken up, you try to in fact plan the activity in such a manner that we actually do this for the chemicals which have lower vapor pressure, and then do this particular assess kind of this what you can say with this particular VOC meter, really trying to look at where are the emissions from these particular joints during the decontamination or the pot emptying out, and based on that can be the further actions. So in this particular case, it's that the IH assessment has happened, and going further, it's also about the workplace exposure monitoring using one of the simplest gadget. Can we move to the next one? Yeah. So in a lot of chemical operations, this is something which is again another one which has a lot of incidents that have happened due to various reasons. And so we'll take up this case study of the reactor cleaning. Next slide. Sorry for that copy paste. It's about the reactor cleaning. So right, so it's a reactor cleaning with 1 hour post the CSE permit has been given. So the actual job is for 1 hour. So in this kind of case, what kind of assessment would we do? Industrial hygiene, process safety. I'm sure we must be having a lot of them who are giving permits or who have given permits sometime in earlier. Anybody wants to take it? Okay, Hita. Anybody else? Hita, I'm not there physically. Otherwise, I generally carry chocolates, to the participants who start answering. So आपको तो बहुत सारे chocolates मिल जाते थे. Right. So in this case, I would personally go for industrial hygiene. And the thing is, from a process, because it's a decontaminated vessel now, and the person has to take entry with the PPs. Now you would say, what kind of industrial hygiene assessments would you carry out? Or what kind of controls? Maybe click one more. Click next. Yeah. So we would actually try to do the monitoring prior to the particular activity. Now, in this case, many of you would actually say that it could be actually a HERA is the right type of tool, which I agree. Even HERA could be used instead of industrial hygiene, the chemical exposure assessment in this case, because quantification of this chemical exposure is difficult. So the right type is actually to have a right kind of procedure, and then do the then actually take up that through the right permit. Just click one more. Just click. Yeah. So I wanted to give one good example here is about GC samplers, and I've used it in past, that where we used some potent chemicals in the whole of the plant. We did have the GC points. So this sampling used to happen. So air was drawn from that particular place and then fed into a particular central point where there was online GC. So online, every 15 minutes, each sample was collected from different parts of the plant, and then it would really give the kind of real-time fugitive emission data. So I just wanted to kind of talk about it. So we used to use those same samplers inside the confined space entry before giving the permit to say whether this is less than that particular whether it can be used, whether that can be used for that particular TLB, whether it is within the TLB limit or not. The other example I wanted to give you, which is not specifically related to the risk assessment after the confined space entry, but for cleaning purpose, what I have been able to do is the kind of cleaning solvents. Now, we talk about hierarchy of controls as first as elimination, substitution. So for a particular reactor, we were using ethylene diamine, which is a respiratory sensitizer. And we were able to actually change that, substitute that cleaning agent. So if there is any possibility of changing, really going to the elimination or substitution, we get that opportunity very less number of times as EHS professionals. But I can tell you cleaning is one of the area where it can be looked at. Okay, we can go to the next one. Right. So in this case, again, it would be really the highest risk, and here it would be tolerable. Let's go to the next slide. Right. So this is the last case study. And in this particular case study, we are looking at fugitive emissions of CMR chemicals. Next slide, please. So it's you can see that we have got different flanges, we have got different instruments, pipes and fittings, and there are CMR chemicals which are used in that particular plant. We have got HVAC system, so everything is closed. So in such kind of case where there is chronic exposure while working in plant due to fugitive emissions, what is the kind of risk assessment? I just really love this person who's written, Avni. Thank you, yeah. Perfect. Good. Great. So both process safety and IH is saying. Okay, Avni, what is the IH assessment that you will do for fugitive emissions? Yeah, so it can be quantitative. I agree. Right. So IH also is possible because we are talking about CMR chemicals. We are talking about real potent chemicals. IH quantitative assessment is required. And from process safety perspective, we can also take it for chronic exposure. But it will be really more centered towards industrial hygiene assessments. We can click on next. And I'll tell you why we should also take it through process safety. We should take it through process safety because there is something called as asset integrity program. We can click one more time. And if you see this picture, it is actually really marking each particular pipe fitting and looking at, I am handling a potent chemical. I've got so many flanges in my plant. What kind of, what type of basically the flange I'm going to use? Am I going to use tongue and groove flanges? Then I'm going to look at, what kind of gasket I'm going to use. Should in some places, should it be really welded joint instead of really trying to have flanges? Should it be a seamless pipe? All of that will actually come from asset integrity program. And asset integrity is another element of process safety. So that's how, in fact, getting this through process safety also will actually drive the asset integrity requirement for the potent chemicals. So both the assessments will be required for fugitive emissions. Let's move to the next one. Yeah, let's go next, right? Yeah, let's move to the next one. Right, okay. So how as an industrial hygienist, we all can help the process safety risk assessors. So the first scenario is about sampling of volatile chemicals in warehouse. Now, the MIE, the minimum ignition energy that is required by solvent, is really 0.2 millijoules, around 0.2 millijoules. And the amount of static that a human being can discharge is actually around 3 millijoules. So this is a very potential case if there is an open sampling happening of volatile chemicals in a warehouse. It's something that you can bring to the notice of a process safety person, that this is a particular risk that, if you have not covered, please try to see if you have covered, because it's about really imagine a fire that occurring in that particular drum when a person is doing that sampling, and then that can lead to really a dominoes effect and the whole warehouse being on fire. Now, in most of pharma, it doesn't happen that way, because we really have the laminar flow boards, but in some chemical other chemical sectors, it does happen that the sampling is done in open in the warehouses. Also, what happens is in a lot of process safety risk assessments, warehouses are not taken as part of the heads of nodes and other things. So warehouses risk assessment in some places do not happen as part of process safety risk assessment as well. So that's something where if you come across, because lot of this sampling activity are covered as an activity in the IH assessment, in the qualitative assessment. So if you come across this, please give that heads up to the process safety risk assessor. The second one is on the acoustic enclosure. This is one of my favorite one, that an industrial hygienist may end up asking to have an acoustic enclosure for noise control. Whereas what happens is the amount of heat that then can be contained could actually sometimes lead to attainment of the auto ignition temperature of certain chemicals. So imagine that a particular blower has been making a lot of noise, and we have put acoustic enclosure on that. And then the temperature is really heating up, and the kind of fumes or the volatiles that are getting extracted from different places do have certain other chemicals, like the CS2 has, I think, around 98 degrees centigrade is the AIT of that. So there could be some other chemicals which have lower, let's say at 60, 65 degrees centigrade. And with this acoustic enclosure, there could be some new kind of a hazard that could be brought in. The other one is hotspots based on qualitative exposure assessments. So while you are doing a walkthrough survey of the plant to see where there are exposure issues, you can please bring it to the notice of the process safety risk assessor to say that this deplugging of the pump is something which is really happening very often. Maybe you're not covered it in your risk assessment, but that's something which can be really actually leading to a flammable atmosphere, leading to a fire scenario. And the last one is basically if there is any powder handling, there is visible dust on the shop floor. Some particular powders have low MIT, which means that if the powder is sitting on the on the hot surface, like you must have heard about imperial sugar, a lot of the imperial sugar explosion that occurred, it did in fact, especially bearings and other things. So if it goes and sits on a hot surface, there can be thermal decomposition that can take place, and it can lead to actually bigger scenarios. So when your observations can be really very important for the organization at large. So these are the certain things which you can pass on. We can move to the next slide. Yeah, so with that, really enjoyed interacting with all of you, and thank you very much.
Thank you, Gitali, for such a very informative and detailed presentation. And we know that industrial hygiene and process safety are correlation. And specifically, we also don't want anything material come out from the pipeline, then people are getting exposed. A similar way in the process safety that do not people or workplace that catching the fire and something where people got exposed. So nice. I mean, your case study was also quite interesting. Comparison of industrial hygiene point of view and process safety point of view. And I'm basically the oil and gas background, so we have always have a challenge for how we can merge the 8x8 matrix of industrial hygiene with process safety. But we do the what if analysis where we involve our industrial hygiene part also. So thanks for sharing, Gitali. Let me see any questions are there in the chat box. No, there was no question. Priyanka, would you like to add up something if you are there?
Yeah. Gitali, I just had one specific question. Great presentation as always. In your professional journey, what have you seen? What has been given like, have you seen any kind of bias with industrial hygiene at times in comparison to process safety? Or you've always seen everything being equal, because your case studies did show some examples where, there are scenarios where both the assessments needs to be done. So we wanted, like, being industrial hygienists, we just want to understand what's the culture in the industry, how are we, and what should we do to be to be different, or give ourselves sufficient amount of weightage at times.
Yeah, I think I think I'll end up giving out my secret here. So, so Priyanka, the thing is that you picked it up well. In fact, you answered half of it. See, as EHS professionals, you got to give that gravity of things to the management when you're conveying certain risk as a risk, or maybe when you're really trying to give a certain business case. So in case of process safety or safety, it's acute, whereas industrial hygiene is chronic. So and unless and maybe in certain Western countries there are regulations because of which it gets driven, whereas in India we do have occupational illnesses and other things, but maybe monitoring and other things are not mandatory. Even the Schedule 2 of Factories Act is not mandatory. It says that if the factory inspector wants, he can be asking. Though in fact, a lot of companies do carry out the Schedule 2 monitoring of chemicals. Coming back to your question, it's that it becomes very easy to say that, see, if we do this, and if I don't have a SIL 1, SIL 2 on this particular reactor, or if I don't do the relief device studies properly and the relief venting is not really assured, or if I don't get the best of automation with the control valve on this particular reactor, it could lead to thermal decomposition scenario, leading to overpressurization, killing multiple people, leading to offsite with the consequence analysis, shut the shop. Very easy to give that message from process safety point of view. And because safety is acute, it always gets, the attention. Whereas industrial hygiene is more softer, it's more chronic. So the way, in fact, one of the things that I've seen, in fact, is that I've tried to also get it through is when we have, if we have, say, issues on the shop floor, I tell guys, HSC committee meetings are your forum, right? Get it through the HSC committee meeting, all of that gets addressed. So those are for the visible ones. And I think it's many a times in EHS, it ends up being the top-down approach, though things are changing now. But I've seen, and I've also seen that at the higher management level, people do want to have right type of EHS, that particular sensitivity. So from industrial hygiene perspective, unless we go and talk and try to show the things, other thing that I say is, we basically are animals, right? I mean, I don't know how many of them will be able to really pick it up so easily, these words. But the thing is that I always say that more than the words and the documents, what is easily understood by everyone is red, amber, green. You make that, right? All your risk assessments should talk red, amber, green. Just give that communication. This is the industrial hygiene assessment. It is into red. And believe me, most of the organizations that I see now in past some years, nobody wants to take a decision saying that I'm operating in a unacceptable region. No leader wants to take that decision. They would say, please tell me, how do I come out from red to amber? Please use these color codes to get EHS going, not for yourself, but for the person on the shop floor.
Yeah.
Very well summarized, Gitali. I really wanted that to go down to all our participants, because I know you have faced it. Many of us have faced it. And I guess coming as an experience from someone like you would have made the difference. So thanks, Gitali, for that. I think, Amit, there is a question as well.
Okay.
I put it on the stage, yeah.
Yeah.
I think it's about surrogate sampling, Gitali. Do you want to pick that up?
Yeah.
Mm-hmm.
Can you share some information about surrogate sampling? Yeah.
Okay, right. I think we probably have lot of experts in this particular in this session. But yes, let me pick it up. So in this surrogate test, basically, like what I've done in past is use things like lactose or any other surrogate which is okay for that particular facility where you're working, right? And try to see before you put really your potent chemical. Try to see do the isolator validation or that validation of that particular place to see if it is achieving the 1/10 of the OEL limit. Now there are surely the ifs and buts and other things where people would say that after all it is about after all it is about the it's that the particle size would change between my actual API versus what surrogate you take, but then you try to actually have it to the best possible. You would do that comparison, especially on the bulk density part of it, and then you would go ahead. So there are some number of surrogate lists which can be used. I hope that answers the question. I've got one more thing which I try to use is the smoke tubes. There are the smoke tubes available from Gastech and Drago. So kind of keep it inside the containment chamber and try to see if that smoke is coming out. So that smoke would be more easier to come out compared to your chemical that you are using. Hope that helps.
Yeah, definitely. I mean, this is a right to give the answer for regarding the surrogate sampling. Gitali, I have one question comes to my mind. In our refinery, we use the 8x8 matrix. We call it as a HITRA register. So consequences part is very much clear for everyone. But in the probability part, normally, in the safety, have a good amount of data like 1 in 10th death or lost time injuries rate and all. So how basically your expertise says that what kind of the metrics we can use for probability purpose?
Okay. For probability purpose, for chemical exposure assessment.
Yeah, chemical exposure without conducting the
chemical
sampling.
exposure, right?
Yeah.
Yeah, exactly. So the qualitative exposure assessment, there I had one slide on that, where we get this severity, as I said, whether we decide whether it's a cow, goat, or it's a tiger, right? So we categorize the chemicals based on the health hazard category. And I'm not somebody who advocates based on OEL limit, because I've seen chemicals which have higher OEL limits, but what it can really chronic way, what it can do is much more. So we do have this, in fact, in the cost assessments also, where we do this health hazard categorization based on the toxicological data. And so that's where my severity comes in, and the probability are different factors. So there are certain some other some other in fact service providers in India also who are doing this, like ISS, then Vanguard, and many more. So they would pick up, and in fact, I have implemented this at my sites, where we then look at how much quantity is handled. So we give different ratings for that. Then what is the vapor pressure or the boiling point of that particular chemical? What is the type of operation? And or maybe whether it's too dusty, it is lesser dustier. So some 4 parameters that we use. I'm sure Priyanka also must have used it in GSK. So with all of that, we do the qualitative assessment. So I find doing the chemical exposure assessment with that mathematical modeling is much easier, basically, compared to the variability is much more with the risk assessors compared to the IH.
Yeah.
I mean, good experience. You've got a very good background.
Okay. Thank you. Thank you very much, Gitali, for your time and presence in our SIHA conference and accept our request to present in this such large international forum. Thank you, Gitali, once again. Yeah.
Thank you. I've enjoyed this session. Thank you very much for everyone around.
Yeah. So now we have a tea break. All of you, please enjoy your tea. And after 15 minutes, we'll be again joining in another session. Thank you, everyone.
Hello and welcome. I think we are a couple minutes late. There's been a little bit of technical difficulty because I live in Italy. And so my internet has been kind of, wonky. I'm going to ask that you go ahead and place yourselves on mute, and we'll go ahead and get started. So Janet is our co-host. If you have any questions, please feel free to send her a message, or you can type something in the chat, let me know. And I think you can probably see Janet there.
Yep. I wish I had time letting people in because it officially doesn't start for a few more minutes.
Perfect. Okay. Fantastic. So I appreciate you all coming. Thank you so much. Looking forward to sharing what we have learned over the last however many years. Between all of us, we have a combined total and of many, many years. So
we have a comment from someone that they're not hearing you.
Not hearing me.
Audio is not on.
My audio is not on.
I can hear you. How about anyone else?
I can hear you too.
Okay.
Okay. So let me see. Is it anyone else that can't hear? So I have my sound all the way up. So please let me know if you can hear me okay now. Okay, how's that?
There's audio now. She's hearing now.
Okay.
Great. Perfect. Great.
Great, thank you so much. I'm gonna hide this little bar. I think I can hide that.
And everyone should be able to, on your own through Zoom, you can set whether you want side by side, what views you want. There are tools within there if you're familiar with it. Up at the very top, if you scroll up there under view options, you have several choices there if you want to view a different way. Everyone has their own preferences.
We don't know if you're on, Microsoft Teams or a Zoom user or the Blue Jean user or what you are. There's so many new things out there because of the pandemic. All right, so Jenna, when are we scheduled to officially start?
15 after the hour.
Oh, okay. I didn't realize that.
So we could do some informal polls.
Perfect.
If people have anything in particular, burning question, we want to make sure that's covered. This would be a great time if you want to post that in the chat, and I'll see anything that appears there.
And if you somehow get booted, just come back in. Janet will let you in as you go through. So that you're aware, I am in Italy. We do have a storm coming through. So if the internet starts to get wonky, Janet has the slides as well, and she'll start stepping through.
Yeah, I will just try to fill in as best as I can. I am not a facilitator. However, I have worked in the process industry for over 20 years. So I'm very familiar with the topic. I have scribed for PHAs, which is not an easy task. You do have to manage emulating the facilitator and not getting in the way of the study.
All right. Hopefully Ron comes on as well. He's gonna, he's available as well. All right. So a little bit about risk. I started this company, what, 12 years ago now, Janet?
Yes.
And when I started the company, I had been in the industry already for a few years, and I wanted a focus on quality. I wanted to focus on quality of the hazard analysis, focus on quality of every element of process safety. And the reason being is that my husband was an operator in a refinery, same refinery that I was a contractor in, same refinery that my brother-in-law was a facilitator in. And there were several incidents. My husband actually came around the corner as a fire broke out in his unit. His unit had high concentrations of H2S, had high pressure hydrogen, and a few other toxic and flammable materials. And he managed to put the pump out, or the pump fire out, fairly quickly, but it came home to me how quickly and how easily I could have lost him. And that particular unit that he worked at had already seen a fire that had taken 4 lives. So when at that point, I wasn't in process safety, but when he came home and told me about everything, I went back the following day and resolved to learn as much about process safety as I could. Since that time, I have seen, unfortunately, a few too many incidents, some that took multiple lives. And I have, they were at facilities that I had not done any work in at that point. But it's a personal thing for me. My husband is now out of the refinery. My brother-in-law has since passed away from things not related to the refinery. And I still have a lot of friends that are in that industry. So I definitely take this as personal for sure. So that is how I got started. When Janet and I started working together, our goal was to build something that was a little bit different. So with that, we decided to put together this webinar series. This one is Process Hazard Analysis. So what does good look like? Because we've seen several examples of some not so good HAZOPs and what if checklists, PHAs. We've seen some examples of mediocre. We've seen some examples of great. And so we wanted to share some of the learnings, the lessons learned over the last few years of what we have come up with, and in conjunction with some of our clients, right? So some of this we've developed with our clients. So really excited to be able to share this with you. Thank you for being here. We'll give a couple more minutes.
Yeah, we're still having a few people just signing in. So we're just getting to the time.
So.
And throughout this, as Renee is giving the presentation, if a question comes up over something she's presenting, please put it in the chat. If it's something, I'm monitoring that. If I think that's something that we immediately need to answer, I'll interrupt Renee and we'll address that immediately. If it's a confusion over something in a slide, happy to clarify. Just say, hey, don't get that part. What did that really mean? Or whatever your question is, and I'll be sure to make sure that's answered. And if there are too many questions to answer at the end, I will be taking a screenshot of all of the chat questions, and anyone we don't answer during the webinar, we'll be reaching out individually to you to make sure that your questions are answered.
Yep, for sure. Sure.
Oh, Ron's joined.
Yep, fantastic.
Thank you for being here, Ron.
Who's still connecting to audio, however. Good question. Is there any connection between chemical engineering principles and the deviations? Well, HAZOP is really, we're looking at what is the worst that can happen if a valve fails. And when you're looking at some of the engineering principles, of course, you want to make sure that you're building it to proper spec and hopefully for safety, right? For ultimate safety. So when we do the HAZOP, we don't necessarily, quote, bring in the engineering principles. However, it is an underlying base of what we're doing. And we're looking at chemical reactions. We're looking at, so some of the chemistry. We're also looking at regularly accepted good engineering practices, so RAGAGAP items as well. So there's a variety of things that so kind of all melds together, if that makes, if that helps your question or answers your question. HAZOP is a very specific type of study that we do for process safety management. All right, so I think we lost Ron. Nope, he's still there. Good. Oh, and Meryl. Hey, Meryl. Okay. How are you doing?
I'm doing great.
Fantastic. Thanks for being here.
Glad to be here.
Okay, so Jana, I'm going to go ahead and start then at 6:15.
I think we're good.
I think we're good. Okay, so thank you again for being here. A couple of you heard why I got started in process safety and risk management is because my husband was involved in an incident at a unit which there had already been a fire that had taken multiple lives. And so it became very personal, very important to me to make sure that there was a lot of focus on safety, and not only on safety, but really doing a good job of maintaining the safety. So that is how I got started in the industry. I have to click over here to do that. Okay, so our agenda for today is to just briefly look at the PSM requirements for PHA. There are a few. We're going to make the case for quality and look at your team, because that's really the first part of, or what I consider the most important part. Then developing your causes, consequences, some SMART recommendations, and of course some Q&A time. So please, as we've mentioned before, if you have any questions, type them in the chat, and Janet will keep an eye out. Hold on just a second while I let my dog out of my office. I didn't realize he'd snuck in here. Real life, right? All right. All right, so under the OSHA PSM requirements, which is where process hazard analysis comes from, we of course want to look at the hazards of the process. We want to look and identify prior incidents that have been involved. We want to consider engineering and administrative controls. the consequence of failure of those controls, facility siting and human factors, qualitative evaluation of safety and health effects. So we need to understand what are the safety and health effects, and it needs to be performed by a team with expertise and address the team's findings. So we won't be covering all of this in depth here. However, there is an ebook that we'll be sending you afterwards that will involve some of the other information that didn't get covered in depth here. So the case for quality can be expensive. We've heard that a lot. Quality is less expensive, however, than a large incident. And if you're going to spend money, make sure you want to spend it right. And sometimes non-safety related benefits, there are some non-safety related benefits of a good PHA. I often hear our process isn't that big, right? However, when that happens, a lot of times your neighbors are right next door. I recently did a PHA where the neighbors were literally across the street from a large methanol storage tank. And it would have taken out the entire, all of the neighbors there if that methanol tank had had an incident. One bad incident can put a small operator or even a large operator out of business. So we want to make sure that we're doing what we're supposed to have it. I've also heard this one. We've never had a serious incident. Well, whenever somebody tells me that, I say, well, are you lucky? You know, because it can happen. Unfortunately, overconfidence does lead to complacency. Normalization of deviation is a regular occurrence in our industry. So if we want to make sure that it stays in the pipes, then we really want to take a look and make sure that we're doing it correctly. When we're doing a PHA, when I do any kind of documentation, I'm always looking to make sure that it's understandable to the people that were not on the PHA team, because this PHA has to be done every 5 years, right? A revalidation or a redo, it has to be looked at every 5 years according to PSM, OSHA's PSM. And if it's not understandable to the people outside of the room, then you haven't done your job well. And that's just how I feel. And so the folks that work with me know that we've got to make sure of that. So what are some of the things to really make sure we get a good PHA, one that's understandable? We look at our facilitators, the team, and we often bring in subject matter experts from outside the room. And we also focus on our documentation. So the team, the technical requirements are an engineer and operator. The engineer can technically be the facilitator. However, a lot of times, if the engineer is a person who's designing it, it's like the fox watching the hen house, right? So we really encourage folks to have a facilitator, whether it's somebody else within your company or a third party, whichever is your preference, but not using the same engineer who designed the process. The other requirement is that the engineer and operator must be experienced on the unit. Now, sometimes I work with teams where the operator or the engineer is a little less experienced than is ideal. So what we'll do is we'll work with that person and have a more senior person available that might come in once an hour, during the day, and maybe a little bit at the end of the week or at the end of the PHA, in order to really make sure that things are done well. So they'll come in at the beginning during the training, let us know what their concerns are, and then move forward from there and be available for questions, right? Some of the other people that might be required, and this might be per corporate or site standards, also it might be based on the complexity of the project that's going on. So we want to take a look and see, if it's a real complex project, you might want to have the instrumentation person available for it for the entire time, depending on what is going on there. So, and like I said, corporates might require other people. You really want a team that's engaged and willingly participating. If you have somebody that is voluntold to be there, it can be a little bit more challenging. And in our ebook, we talk a little bit about how to deal with that. when you have that, but really keeping them engaged really helps keep the PHA quality high because they have a vested interest in what's going on. And we want to also focus on the fact that, when we're discussing potential incidents, it's not a reflection of the competence of the engineer who designed it or the operator who is operating the system. So when I ask questions, about what might happen, it's really to understand what is the worst case that can occur. If the engineer starts to get upset about, well, you're questioning the competence of my PHA or of my unit, well, no, I'm really not. I'm challenging so that we make sure that we have the right safeguards in place. Or if the operator starts to get a little irritated about, well, you're telling me that I'm not doing my job, I'm like, no, I'm just making sure that your job is as easy as it can be, given the fact that you're dealing with hazardous chemicals, right? So we want to make sure that you have the right safeguards in place, that your procedures are easy for you to understand, et cetera. So, when you're dealing with a team like that, how you approach the team can really make a difference in their willingness to stay engaged in the team. Your team is really important, so work to keep them involved. The facilitator is also important because they have to confront some of the biases that might happen. I hear a lot of times that, well, this will never happen on my unit. Okay, that's a bias, right? That's a bias that can never happen. I've been also been told that everything's going to blow up and everyone's going to die. That's another type of bias. And so there's a balancing act that has to happen here when we're working with some of the processes and dealing with people that are on one side of the equation versus somebody who's on the other side. And sometimes you have both in the room and they go head to head. So you need to understand how to address that as well. Looking at who are the personalities on your team. You might have a team member that wants to bulldoze right over the top of everyone. So it's the facilitator's job to help manage that person. And it can be a challenge. A good facilitator, however, can handle that person and calm them down and bring the other people that might be a little bit more reticent out, get them to speak up a little bit more. So that's part of the job of the facilitator. It's also, you want the facilitator to be able to handle some of those sidebar conversations. I've had times in the room where I've had multiple conversations going on, and at times it's okay because of what's happening at that precise moment, but most of the time it's not. And so I have to focus on making sure everybody's kind of, hey, stay engaged here. Come back to me right here at this point. And so I work on doing that. I make sure that I have the correct subject matter experts for whatever is happening at that particular time. I might not have for example, a rotating equipment person available the entire time. However, if we're going to be talking about a compressor or a pump, I definitely want to have that rotating equipment person in. So if my site representative hasn't already scheduled them to come in, I'm going to be focusing on, hey, Mr. Site or Mrs. Site representative, can you please bring this person in? We're coming up on the compressor unit. We want to make sure that we have the right people there. The facilitator is also responsible for doing daily cleanup, just to stay on top of everything that's going on, to make sure that everything was really covered. So we look at every time a valve malfunctions open, malfunctions closed. So for some of the nightly cleanup might be just simply looking at, did we consider every single time, every valve open and every valve closed, right? Keeping track of parking lot items, recognizing best practices and norms. If there's consequence modeling available, we want to make sure that we can use that. And of course, creating reports. SMEs, we want to bring them in whenever we can. Rotating equipment, chemists, metallurgists, there's a variety of subject matter experts. Sometimes they're third parties, sometimes they're within an organization. Working with up-to-date P&IDs, that is ideal. Not always possible. So making red lines, assigning that to somebody on the team is the best way of handling that. All of the equipment data that is available, we want to make use of it as best we can when we need it. If it's not available at the moment, we put a parking lot on them in order to find the information and bring it back. Of course, there's other documentation that might be required, PFDs, MSDSs, consequence modeling, even operating procedures. Right? So if we look at operating procedures, the operator will tell me, oh, we do, that's in our procedures. So I pull up the procedure to see, is it really there? You'd be surprised at how often it's not. Okay. You might consider doing a field walk, right? So the reason for doing a field walk is simply for the, to kind of take a look at the unit to see about when you're getting ready for your facility siding or your human factors, to see how everything kind of is together, how close everything is, how accessible everything is. You're looking at ergonomics, visibility. Are there, is escape easy for the operators, et cetera. So take note of some of the items that you might see when you're walking through that might impact the hazards of the process hazards of that particular unit. Then when we get into the documentation, the first thing is the causes, and causes are specific. They must be credible within the node. So we separated everything into the node. Your causes must be within the node. We don't look at double jeopardy. I'll talk about that in just a moment. We consider different modes of operation and different consequences. So a cause must be specific. So we will, the reason for this is the number of times that I've come back to an older PHA that somebody has done. And quite honestly, some of them I have done in the past. So I've learned some of my own lessons. We want to make sure that we specify which valve, because if we just say, oh, that control valve, the inlet to whatever unit, or the inlet to whatever piece of equipment, sometimes things change. So if we put a valve number and we say it malfunctions open, then this gives you the valve number. If you say because some valves are, based on design, they might say, well, that's a fail open valve. Okay, well, then it malfunctions open when you're expecting it to be closed, right? Causes must be credible. So for example, plugging a normal service for a 1/4-inch tubing might be credible, but not for a 6-inch process line. And maybe for that particular process, a 6-inch process line, plugging might be possible, but a 12-inch might not be. So depending on the process, what is credible in that process? Within the node, the exception of this is really at the beginning or the end of the process, because you might have some boundary pieces of equipment in the boundary between this part of the process and that process unit. I found equipment in in a refinery that I worked at that had never been looked at. A couple of exchangers and pumps nobody had ever looked at, because it was in that boundary between this process and that process. So you want to really be careful when you're at the boundary and make sure that you're looking at the equipment there as well. Double jeopardy. Okay, this one is a funny one because a lot of people want to say, oh, well, that's double jeopardy. Really, if there are multiple independent failures that must occur in order for it to occur, then yes, that's double jeopardy. However, if multiple manual actions are performed together as part of the same procedure, they're really not independent of each other. So we might consider that not being double jeopardy. So we would consider that particular scenario. As an example, an operator must open a manual valve on a vessel A and close a manual valve on B. And he inadvertently opens the opposing, right? Modes of operation. We really want to look at different modes of operation. normal plant operation. Alternate plant operations, a lot of times a valve malfunctioning open in normal plant operation is not a problem, but during regeneration or cleaning in place, it might be, you might want that closed. Startup, shutdown, maintenance are also areas of concern. 70 to 80% of incidents, depending on who you're talking to, occur in these portions here: alternate plant operation, startup, shutdown, and maintenance. So you really want to ask the question, do you have an alternate plant operation that you do here? Do you have a regen operation? Do you have drying? Do you have a turn down, where you go into circulation or something along those lines? Developing a cause for different consequences. Oh, this should probably be down in the consequences. Okay, flow control, or you might have different consequences for the same cause. So consequence one, you might end up with a vapor cloud explosion with flash fire, and another consequence might be a pool fire. And you might separate those out, you might not, depending again. Vapor clouds, you might have different safeguards. So again, depending on your process, a lot of times it makes sense to have two separate consequences because you might have different safeguards for the consequences. So be aware of that as well, where it's the same cause. Are we okay at this point? Everybody, no questions yet? Okay. So consequences. We're
no
good?
questions yet. We're good.
Okay, good. Okay, so consequences. This is where the story gets developed, right? And in the past, it used to be kind of a laundry list. You might see a laundry list. I still see that on occasion. We want to, if you write a story, it makes it easier to understand, only because then for me personally, and for the companies that I've been working with most recently, it makes it easier to figure out where we can stop the consequence from occurring, right? So if you have a story, I can stop it here at this point, I can stop it here, or I can stop it here before it gets to that final stage. So the consequence must be credible, developed without safeguards. Okay, this is a hard one, especially for folks that have been in the unit for a while. And you want to follow consequences all the way to completion. The consequences might be downstream in another unit, right? They should be sequential, detailed, and describe the full impact. You want to consider the non-standard operating modes and look at multiple consequences from a single cause. We really, you must extend it to the worst plausible outcome, right? Plant trip or shutdown is not the worst plausible outcome. Plant trip is your safeguard, a shutdown is a safeguard, right? Those are things that are stopping the bad thing from happening. So when you're developing the consequences, considering that the operator is not available, maybe he's over changing out a pump somewhere else. Control valves are in manual. You might have them in manual for because you're getting ready to test something. Alarms and safety interlocks don't function properly. Multiple incidents over time have occurred because of those, exactly that right there. Procedures are not clearly written, followed, or understood, right? So tribal knowledge is a real thing, right? So even though you might have a procedure, you might hear that it's not well written, or, well, we don't really do it that way because, this is really a better way to do it. So we take that into consideration when we're developing our consequence. A common error by a PHA team is to take credit for a safeguard when developing the consequences. And I can tell you 90% of the time when I'm working with a team for the first time, that first day or two, I'm constantly saying, that's a safeguard, that's a safeguard, that's a safeguard, right? So an example would be, we take it all the way to the possible loss of containment, resulting in vapor cloud, fire explosion, boom. And so we might have personnel exposure. So here you might have somebody saying, well, we're going to have increased pressure up to a PSV lifting, or we're going to have high level in the separator leading to a plant trip. Okay, those are both safeguards. Now, this one here, the PSV lifting, that's another can of worms I'm going to go ahead and open. If the PSV does not lift to a flare or to a safe location, there might be a secondary scenario here. So you might have, fire explosion, boom, and then your safeguard is the PSV. And then you say, and if then you have a second scenario that says, and if the PSV lifts as expected, now we have a potential for personnel exposure to whatever the material happens to be. So now you need to see, do you have the proper safeguards in place for that exposure? One cause, multiple consequences. Yes, I would divide them into different scenarios. Thank you for that, Paula. For sure, if you just make another line item and you have different scenarios for sure. So it'd be a deviation, a cause, a consequence is one scenario. And so you might have another deviation cause with a second consequence. Okay. Sorry, I missed that question till just now. When you're developing your consequences, you want them to be sequential. Okay. The reason for that, again, is you might have different safeguards at different points. So sequential, they're detailed, and your final step is the consequence is the impact to personnel, public, or the environment. So increased flow of feed gas to the separator. So the valve malfunctioned open. Now you have increased flow of feed gas to the separator. So maybe you have a flow meter that tells you have high flow, resulting in increased separation with potential for increased level in S101. So now you might have a high level shutdown for that particular situation, resulting in high pressure gas in the separator. You might have a high pressure alarm or a PSV. So now by writing this all out, it makes it really easy to see when you start lifting your safeguards, what safeguards are going to help you in what place along the way. Do you have something that's going to stop it before it gets all the way to fire explosion and boom? Okay. Does that make sense? Oh. And we tend to list our safeguards in the order in which they're going to occur. We don't tend to. That's what we encourage. Listing the safeguards in the order in which they're going to occur, because then it's very clear to see where they happen in the sequence of events. Okay, non-standard operating modes. XV101 malfunctions open during normal operation. So during normal operation, it's open, so not a consequence of PHA concern. However, if that should be a 1, sorry. Malfunctions open when it should be closed to a secondary tank. So if they're maybe in a transfer, you might have misdirected flow to another tank, resulting in a high level in the tank. O2 with potential overflow through the gooseneck to a secondary containment, resulting in pool fire. And now we have personal exposure, right? You might have a note here that, okay, we don't really have people in the storage tank area, so we would reduce the frequency of, or depending on how your risk ranking is set up, reduce your frequency by an order of magnitude. Questions? All right, potential for multiple consequences from a single cause. Here we go. Here's a question. You might have upstream and downstream consequences. So, okay, Mohammed, I'm going to go ahead and answer your question here. Only if the PSV is lifting to an unsafe location, like lifting to where a walkway is. I actually have seen where PSVs lift and they're directed right where somebody might be walking. And so that's not safe, right? Because now you have the potential for exposure and personnel, somebody's walking through that area. So if it's going to a safe location, then PSV is a safety measure, and it should be, in theory, installed to discharge to a safe location. Unfortunately, I've seen it installed incorrectly, or another plant has built up around it, and so when it lifted, it actually lifted right into a walkway. So, yeah. So we did a secondary scenario. So back to the multiple consequences from a single cause, we have upstream and downstream consequences. We want to take a look at that because a lot of times there are scenarios for in both directions. In this one, there's not. It's just a business interruption in the one direction, but there's a potential for high pressure and jet fired in the other direction. Okay. If the consequence does not warrant a severity ranking, it should still be explained. And the reason for that, I also do a lot of auditing. And so if I'm auditing somebody's PHA and they just say, no, there's nothing there. I'm like, well, really? Did you even talk about it? Right. So I've opened up PHAs where there's like whole nodes without anything in it, but I see all these different valves and all these different pieces of equipment. And I'm wondering, did you miss this? Right. So make a couple of notes and just say it's an operational issue only, not a PHA consequence of concern. That makes it easy for an auditor to see that, yes, you have discussed it. It also makes it easy for the team 5 years from now to see that, yes, you've discussed it. And if you've made any changes in the process, you can say, well, it used to be safe, and now we've made some changes to the process. Is it still safe? And maybe it's not anymore. So make some kind of note. It doesn't have to be a full-blown description, but definitely put something in there that lets people know you've talked about it. Yep, let's auditors and future teams know that you discussed the potential hazards. Okay. All right, before I move to safeguards, are there any other questions about the consequences? Various causes of less or low flow can be a valve partially closing. I've seen that, or a pump. If you have a variable speed pump going to, a lower flow definitely can be a cause for that. That's, I think, probably the most common for low flow is a variable speed. All right. Any other questions about the consequences before I move forward? All right. Then safeguards. So safeguards must be able to detect, prevent, or mitigate a scenario. Okay. So you want it to be one of these three things: detect, prevent, or mitigate. Ideally should be independent from the cause and other safeguards. I realize that is not an actual requirement, but it definitely is something you want it to be to consider. It is a requirement if you're doing a LOPA, just so you're aware. You want it to be detailed enough to be clear how it's a safeguard. Just simply saying that you have a high-level alarm, okay. If that's a unit that has a lot of alarms, how is that high-level alarm going to be of value to you? Does it tell the operator what to do, right? So you want to know, how is it going to be a safeguard? Is it going to shut down the right thing? Is it going to protect you? Safeguards that detect and indicate what the operator action is in order to indicate how it's safeguards. So PHA high pressure alarm alerts operations to open the quench valve. So when we write out our safeguards, we give the information of what the operator is going to do if they get that alarm. Safeguards that prevent right? So it's designed to prevent the scenario, and you want to make sure that it's designed to prevent this scenario and this question. So PSV set at 150 PSIG protects separator 101, which is an MAWP of 150 PSIG. It relieves to a safe location, maybe it's a flare. It's sized for whatever the vapor relief pressure is. Or another one might be that you have a high pressure shutdown on the compressor to shut everything down. So give some information to say exactly what it is. Give the tag number, right? Give, say what it's protecting, say what it's sized for, say what it's doing, so that you have enough information to really know, does it protect you? And the reason for this is because in the past, people would just copy and paste a whole scenario into other places and then not look to see if the safeguards would protect against that particular cause-consequence pairing. And yes, Paula, for sure. You want something, so we'll talk about that here in just a moment. Mitigation, no more than one mitigative safeguard per scenario is recommended. Okay, that's just a recommendation. I've seen that in many of my clients' sites where they don't even, I have a couple of clients that don't even want you to credit mitigative safeguards because now it's outside the pipes, right? So you kind of have to understand what your site requirements are, your site preferences are, and then go from there. But some of the mitigative would be deluge systems, fire monitors, blast walls, right? So there are a few things like that. So, let's see, what do I have here? Yeah, I'm going to come back here. So detecting something is really good because you can stop something from happening. The operator might be able to stop something from happening before you get to the bad thing. But something that's going to prevent it is going to be an automatic shutdown. So that if it's a really high risk, yes, Paula, for something that is in high risk in the ALARP region, then you want something that's going to be a preventative for sure. And again, like I said, a lot of places won't even allow you to count unmitigative. So just be aware of that. Okay, safeguards. They really should be independent from the cause and other safeguards. And the reason being is because there's so many components, like for a level controller, for example, there's so many parts of a level controller. A transmitter could take out your controller, take out your alarm, and maybe even impact your interlock. So if they're independent of each other, then they can be more, they're just better protection, right? So level controller will close FCV 100 on high level. That may not be sufficient because it's the same, right? That level controller malfunction open. But if that's the malfunctioning thing, how's it going to close that FCV? It might be that transmitter that went bad and now it's not going to close that high level. Or even the alarm. You may not get the alarm because the transmitter, right? So having something that's independent of the other safeguards is really, it's just better. It's just better. Level controller's failure mechanism for safeguard is also the failure. If the level alarm is on the same instrumentation loop as the level controller, it's not independent of the failure, may not be sufficient. And yes, please add your response time. If you don't have, because response time, if you don't have enough response time for the operator to go out to the field to take care of it, then it's not a good safeguard. Also, add as much detail as you can to your safeguards. I have started doing this many years ago where this LSH is associated with the separator 101. It makes it really easy because we use software, PHA Pro software, which has a nice little drop-down menu. So it makes it very easy. Unfortunately, some of the other software out there does not. However, now I can look and see every safeguard that's associated with the separator, right? That's why I write them up this way. But here's a well-defined safeguard. You have a high-level switch. It's going to close the valve at 90% level and shut down your feed gas compressor. It doesn't have to be linked to a procedure. I just associate it with that just because it makes it easier for me to know all of the different safeguards that are associated with the separator. But if you just say there's a high-level switch, what does that tell you? Okay, there's a high-level switch. Great. Right. So whenever somebody goes, well, I have a high-level switch here, I'm like, okay, nice. But what's it going to do for me? What's it going to do for me? How's it going to protect the operators out in the field? Right. Well, it's going to close the valve and shut down the feed gas compressor. That's what it's going to do. So now I know how my operators are going to be protected. When's a safeguard not a safeguard? All right. We talked about this one already. If the PSV lifts, right? So here we have the FCV malfunctions open. We're going to have increased flow of gas. There's a whole bunch of stuff in between there that now is going to lead to an overpressure of separator with loss of containment and high pressure gas. So our PSV is going to keep the separator from going boom, right? So it does protect the separator. However, it may also be its own consequence. So we say if PSV lifts as designed, it could send high pressure vapor to the walkway above the building. And it just, if there's an actual walkway, there's a potential for personnel exposure. And now, is there something up there that's going to protect people and let them know that there's been a release, right? So it may be a different scenario. It may not be a scenario for you. That's okay. But if it's lifting directly into a walkway, please go ahead and identify the fact that the PSV might be lifting and sending product to the walkway. So this one here for me is a big deal because my husband was out in the unit. We were just talking about this particular scenario just the other day. A PSV lifted when the overhead condensers got closed off and they were shutting down the unit. And I mentioned that the unit that he worked on had already had a fire that had killed 4 people just prior to him coming to that particular unit. And so he was out. They knew they were bringing the unit down. Somebody closed the wrong valve. They shut the unit down. And because the overhead condensers, because they shut the wrong valves down, these PSVs started raining gasoline. So my husband's out in a unit, hot equipment everywhere with gasoline raining down on him. Right. So if the PSV is not going to a flare, is not going to a safe location, is not directed in such a way, please go ahead and include your PSV lifting as expected to keep things from going boom. It kept the overhead compressor from going, overhead condensers from going boom, but it created another hazard. Does that make sense?
Yes.
Thank you.
Yes, it makes sense.
Okay, great. Thank you. Some safeguards may only be valid for some of the consequences from the same cause. So that's another thing as well as you want to take a look and really don't just cut and paste, copy and paste, because every safeguard may not be valid for every cause consequence pairing. So just be aware of that as well. Any more questions about safeguards before I move into recommendations? Fabulous. Okay, so recommendations. Recommendations is what I was dealing with before the incident with my husband. I was trying to clean up somebody else's recommendations, and there were a lot of them that it was very hard to follow what it was that they were trying to write. So here I am at this refinery, and my first job is dealing with closing out old recommendations. And so I have a lot of passion around how recommendations are written. One thing, so you want to make sure that they're written. Oh, there we go. If there's an existing systems and administrative controls are not likely to prevent or sufficiently mitigate a consequence, then go ahead and write up a recommendation. If there's a scenario with a risk ranking that requires a recommendation. Okay, so there are different guidelines, different clients have different guidelines. They may, you may not have to write something up unless there's a certain level of risk gap still associated with them. If there's an operability concern that's sufficiently severe for a scenario, then go ahead and write up a scenario. Again, if it's within the parameters of your client, if your company, your client, right? If there's a shortfall in compliance with a regulation or industry standards. So Paula, way back at the beginning, you asked about the design, engineering design, everything like that. That's where this for sure comes into play. If there's a shortfall in compliance, I was dealing with a chlorine site and they were missing some of the required safeguards for that particular site. And so we, of course, made some recommendations to ensure that they had them. So you have to know what you're dealing with when you walk in. Okay. And I can't say this enough. If a recommendation is associated with multiple cause consequence pairs, same with safeguards, right? When you're looking at your recommendations, make sure that it's really going to be effective for that particular scenario. Is it going to prevent, is it going to detect, prevent, or mitigate the consequences of every scenario with which that recommendation is referenced, right? So you might, if you're doing this copy, paste, copy, paste, copy, paste, make sure you review your cause, your consequence, your safeguards, and your recommendations, and your risk ranking, by the way. It should be smart. I think at this point, a lot of people know your recommendations should always be smart, but it bears always to take note of it. Specific. You want to make sure that your wording is gives a lot of information, right? We'll go through some examples here. So you really wanted to make sure that, and I really focus on making sure that they're standalone, because I don't know about you guys, but I don't want to look through 700 pages to find my recommendation and where it's at. So I give enough information in my recommendations to make sure that somebody outside of that team is, when they see it, they're going to know what all is involved and why, okay? Include your equipment numbers, your line numbers, your drawings that are relevant, what procedures that are relevant, any relevant information, any tags, anything that you possibly can have, add that in your recommendation, right? You want to make sure it's measurable. So can they accomplish this particular recommendation? I have received phone calls from clients that have said, Renee, we have this old recommendation from somewhere else. Can you please help me? How am I going to close this? Like it's a never-ending kind of thing where it's just a perpetual. How do I close this? Right. So make sure it's something that they can accomplish. There's a clear point of closure on this particular recommendation. Accountable, so now this part, you might not do it during the PHA. This might be assigned later, but there's a closeout meeting. We try and have a closeout meeting, but where somebody is assigned a responsible party. Make sure it's relevant. Is it going to directly impact the risk and, detect, prevent, mitigate this scenario, and time limited? So OSHA does require and does expect that you're going to do things in a certain period of time. Many companies have now set guidelines. If it's this level of risk, then you have to do it in this period of time, this level of risk, that period of time, whatever it happens to be. Just be aware of that. If you're a third party, even in your own organization, be aware of those things when you're going into it. An example. So here's my basis. So implement an additional level transmitter with high level alarm or other indication to alert the operator of increased flow pressure to separator 101 or level in the separator. And then we give this whole, here's why, right? Here's why we made this recommendation. And had people done that when I first started closing out recommendations, I can assure you it would have been easier. Okay. If there's no risk or gap, a recommendation may not be necessary. However, there might be some process improvements. So you might keep a separate log that, it's like, okay, here are some process improvements that you became aware of during your PHA. Some sites allow you to add those kind of recommendations. More and more people are not, but be aware of that in your own organization, or if you're a third party. Process improvement log is really useful. Here, this is a fun one, right? Teams like to solve problems. I don't know if any of you have been in teams, but right. Teams like to solve problems. Many of you are engineers and you like to solve problems. So when you're in a conversation around a recommendation, there might be a couple things that are readily available, and go ahead and put that down, as a consider, or consider is one of those things that people don't like to so much anymore, because they're going, oh, well, I considered it, so I didn't do it. So you want to give a little bit of wiggle room, because you may not know all the answers. You may not have all the information. So be aware of that when you're writing your recommendation, because when the design team comes in, they might see another alternative or another solution. You might, if you have a couple of alternatives that you think of, you might go ahead and write those out.
Renee, there was a question on a recommendation. If the recommendation will be completed in a significant due time over 3 months, is it recommended to have an interim measure?
So it really depends. Again, it's a client. Some clients allow 6 months. If it's clear that a shutdown is required and the gap is a large enough gap, or the risk is a large enough risk, then you may want to go ahead and put a second recommendation. And so I wouldn't write it as one recommendation. I would write it as two, and I would say this is short term, and here's for closeout, right? So you might do it that way. So again, it's based on client. Different sites have different requirements. Some sites, if it's a certain level of risk, you have to close it within this period of time, this level of risk, that period of time, et cetera. So just be aware of those levels of time. Thanks, Janet. Okay. Any other questions on recommendations before I move forward? All right. Global node. So global node is something that we have added. Not every company has these. Not every client we've worked with has done this. We've added it to all of the templates that we work with, because there are those areas like bleeds left open, or loss of utilities that would impact the entire unit, or weather issues for sure would be in those areas that I would consider kind of a global kind of concept. And so we've created this global node because they're common cause failures, like the loss of power, utilities. It's got all of your safeguards if you lose power, potentially. Some of your safeguards might be on air, right? So if you take out the power and you lose those safeguards, now what do you have? Do you only have mitigative? Okay, so this is also a good place where you might call out, because you don't want to list, fire monitors and emergency response and everything on every single scenario, which, by the way, I have seen done in some of the older PHAs. So go ahead and create this tier where you go ahead and list all of the mitigative safeguards that you have. You know that you've got the emergency response. You've got flood weather-related safeguards. You have a corrosion under insulation process that you look at. Whatever it might be, class 1, div 2, or ATEX zone 1, whatever, depending on what country you're in, you'll classify it differently. So those are a good place to go ahead and list all of those safeguards for some of the appropriate types of places where you would need them. And if you do create a global node, resist just clicking through it. Really take a walkthrough through it, because, by the way, we've come across some really interesting scenarios that have been major big booms for certain sites. All right. Okay, closeout meeting. Review of parking lot items. So we try to always have a closeout meeting before we leave a site. That's not always possible. Sometimes we have to do it over a WebEx or Zoom or whatever process. But it's a really good place to review the parking lot items, right? If you had a laundry list of parking lot items, you want to make sure that they were all addressed. If they weren't addressed, then you want to make sure that they are assigned to people, that they're going to get all that information back to you so that you can finish this up. And you might have to schedule a meeting to go through a few scenarios at the end of the PHA if not all the parking lot items were covered. It's also a good time to review recommendations for clarity. Make sure that everybody's on the same page, that, you know, if you're 3 weeks later and that first recommendation, you're kind of looking at it going, what were we thinking when we did that? Then it's a really good time to take a look at it. Bring in your upper management, other stakeholders into your closeout meeting. Sometimes they have information that you didn't think of. When when you get into PHA, sometimes you get into that tunnel vision and you don't see a different way of looking at something. You forget about something. You forgot about, oh yeah, we have that we added, or whatever it might be. So they might, when you bring them into the room, they might bring into that conversation another safeguard that you hadn't thought of. At that point, some sites assign recommendation owners, like the project team, process engineer, et cetera, whoever it might be, and they go from there. So, all right. Any questions? Any additional questions? We've had several great questions throughout the call, and I appreciate that to everybody who's submitted them. All right.
Good job. Thank you.
Thank you.
Very well done.
Thank you.
Sorry.
Oh, how to capture damage mechanism in a PHA. So damage mechanism. Okay. So there are a couple of different ways depending on the damage mechanism, right? So really good question. Let me think about this for a second. I guess it will depend on the scenario. So corrosion can be captured under specific nodes sometimes, or sometimes under the global node. Some of the other damage mechanisms, erosion, a pump failure, I would do right within the node. So are there any others in particular that you're thinking of as we go when you ask that question? Any other specific damage? Yeah, so I would do it. I don't know if you're still here or not. Yeah. Okay. Well, I would do it within the node if I could, and the failure, whatever the failure might be, because it could be the pump fails. That might be the damage mechanism. If you exceed the MAWP or the MAWT, that is probably because something else caused it. Not probably, it is because something else caused the high temperature that led to you exceeding the MAWT. if you exceed the MAWP, it's something because something caused the higher pressure and you exceeded the MAWP. And so now you have this damage to this particular piece of equipment. So, any others? Does that answer your question? Okay, good. I see. Okay. All right. Thank you, everyone. I appreciate you being here. If you have any further questions, please feel free. Janet will, startup shutdown. Is it okay to? Yes, it is okay to take a procedural review. So a procedural PHA can be a little bit trickier. And so when you're doing startup shutdown, you really want to ask the question, look at it from, do you have enough time? I didn't even add procedural PHAs in here. Do you have enough time for this step? Are they in the correct order? If you do it out of order, is there a consequence, right? So the very first procedural PHA I ever did was for startup of a new unit. And if they had done it in the order that it was written, so the unit wasn't started yet, it was a project, right? So the procedure was written, and it was such that if that had been done in the order as written, it's not a question of somebody might have died. It was they would have died. So you want to ask, if you do this in the right or wrong order, is someone going to die? So you have to be sure that the procedure has big, bold, do it in this order. The other thing that I came across in another procedure is that it wasn't clear. There were two valves that had to be opened almost simultaneously, and they were a mile apart. So it needed a second person. No problem. So you needed a second person to be able to start the, to open the two valves. So they had to add a step in the procedure to call somebody else out to open up that other valve. So definitely when you're looking at procedures, thank you everyone for coming. When you're looking at procedures, ask some of those questions and ask, does it matter that the temperature, if it's a little bit less, a little bit more, if it's a little bit longer or a little bit less time, rate of starting up can sometimes be a big issue in certain units. You can lead to runaway, right? So ask for those kinds of things as well. Yes, so documentation that you can read to assign the value. Yes, we're going to send out an ebook to everybody, and so everybody that was here, Janice taken note of you, and she will definitely get you all the information. For a safeguard to reduce the risk there, so CCPS has a couple of books out on value to, on how to set things up or how to assign value to different safeguards based on industry practices and probabilities of failure on demand. And there's a whole laundry list of information out there. So feel free to, Janet, did you?
There are many resources on our website that link to these various resources that can support you. If you go to our website and click on the resources tab, that's where you signed up for this webinar. There's a whole bunch of links there to industry. Some are specific to, to the chlorine industry, to ammonia registration. It kind of depends on what you're looking for. And there's a link to CCPS, which is an incredible resource. The other thing that's really a great resource is the Chemical Safety Board, because you learn so much from incidents. You learn of things to be aware of, and lots of resources there. So please explore that. You can ask me questions. I'll be sending out an email thanking you and giving you the ebook, a link to the replay, and how to contact us if you have further questions or want to set up. You're welcome to set up a personal conversation with us if you want to discuss your specific site and specific questions you have about your company. I've got a few companies that came to this and they want to set up a private repeat of this with their company and include more people in their company and discuss their specific issues. So there's a lot, we can do a lot. Just let me know how we can support you. That's what we're here for.
Yes. Thank you, everybody, for coming and participating. Thank you for the great questions. Appreciate it very much. And we will, like Janet said, she'll send out an email. There'll be a link for the presentation, as well as an ebook that has even more information than was presented here today.
Thank you very much.
Thank you.
Thank you all.
All right. Bye.